From the explosive power of gamma bursts to the captivating mystery of black holes, certain cosmic phenomena continue to challenge and redefine our understanding of the universe. These events do more than just stretch the limits of science. They echo through human culture and history, altering how we perceive our place in the cosmos. Today, we embark on a journey to explore the science behind these monumental occurrences and investigate how they illuminate not just the sky, but our very existence. Together, we'll uncover the largest cosmic events that, while far beyond our reach, will leave their mark on the universe. One of the most awe-inspiring events on the horizon is the predicted collision of our Milky Way galaxy with the Andromeda galaxy. Set to unfold approximately 4 billion years from now, this cosmic collision promises to reshape both galaxies in ways that are difficult to fully comprehend. Though it might seem distant, almost irrelevant on human timescales, the merging of these two massive cosmic structures will be a spectacle beyond imagination. Stars within each galaxy are not likely to collide directly due to the vast emptiness between them. However, the gravitational forces exerted by these giant galaxies will trigger dramatic transformations. As the two galaxies spiral together, their structures could be radically altered, and it is even possible that a new galaxy could emerge from their union. As we gaze farther into the future, another cosmic event looms large, the end of our sun's life cycle. In about 5 billion years, our sun will exhaust the hydrogen fuel in its core. When that day arrives, it will enter a phase known as the red giant stage, swelling in size and growing increasingly unstable. As it expands, it may engulf the inner planets, including Earth. Although this sounds like a cataclysmic event, it will also result in the creation of a planetary nebula, a beautiful, colorful cloud of gas and dust ejected into space. At the heart of this nebula, the core of the sun will remain as a white dwarf, a remnant of its once mighty self. This dramatic end offers a stark glimpse into the future of our solar system, where the legacy of our sun will continue to affect the space around it. Meanwhile, gravitational wave detection has unlocked a new frontier in our understanding of the universe. These ripples in space-time, caused by powerful cosmic events like the collision of black holes or neutron stars, have given scientists an unprecedented tool for probing the cosmos. The study of these waves opens exciting new possibilities for understanding how space and time bend and warp in extreme environments. Every detection reveals a cosmic drama playing out far beyond our reach, events that challenge the very fabric of physics itself. These discoveries have the potential to shift our entire perspective on the laws that govern the universe. Closer to home, astronomers are keeping a watchful eye on massive stars nearing the end of their lives. If a nearby star were to explode in a supernova, it could light up the night sky in a spectacular display, offering scientists invaluable data on stellar evolution and the forces at play in these extraordinary explosions. Fortunately, for the time being, these cosmic explosions are not a direct threat to Earth, but they do remind us of the dynamic and unpredictable nature of the universe in which we live. While these events may seem distant or abstract, certain cosmic phenomena captivate our attention more vividly due to their rarity, scale, and the unique perspectives they offer on the universe. Total solar eclipses, for example, occur when the moon completely obscures the sun. These celestial spectacles happen only once every 18 months somewhere on Earth, and they offer a breathtaking transformation of daylight into twilight. During an eclipse, we can glimpse the sun's corona, its outermost layer, an otherwise hidden feature that becomes visible only under these extraordinary circumstances. Due to their rarity and the sheer beauty of the moment, solar eclipses leave lasting memories for those lucky enough to witness them. In contrast, more common cosmic events like meteor showers or the passing of comets, while still awe-inspiring, are often overlooked. Comets, which appear only once in a lifetime, can be subtle in their display, leaving observers to wonder if they missed the event altogether. Meteor showers, though occasionally dazzling, are often disappointing when the sky doesn't deliver the expected spectacle. These everyday occurrences, while still captivating, do not evoke the same sense of wonder and excitement as the grander, more dramatic cosmic phenomena. The scale of an event is a critical factor in how we perceive its significance. Cataclysmic events like supernovae or galaxy collisions not only affect the immediate surroundings, but ripple out across vast stretches of space, providing us with profound insight into the workings of the universe. Such events, though far beyond our ability to experience them firsthand, allow us to study the fundamental nature of stellar evolution and the intricate structures that shape the cosmos. Their impact is felt across light years of space, and their consequences can alter entire regions of the universe. This makes them essential subjects of scientific study as they contribute to our understanding of the very building blocks of the cosmos. These cosmic phenomena are more than just distant curiosities. They are milestones in the grand story of the universe. As science progresses and our understanding deepens, we will continue to look toward the heavens, seeking answers to questions that have puzzled us for millennia. And as we do, we will uncover new layers of the cosmos, revealing the interconnectedness of everything, from the smallest atoms to the largest galaxies, all bound together in a vast, ever-evolving cosmic dance. Cosmic events are rarely witnessed without the right confluence of time, place, and technological progress. The significance and visibility of these phenomena can drastically change depending on when they occur. For example, when a major scientific breakthrough or a new technological advancement in observational tools aligns with a cosmic event, it amplifies interest and draws attention. The precise moment a celestial occurrence becomes visible, coupled with its scientific implications, can elevate it to the realm of unmissable events. This interaction of rarity, dramatic visual impact, sheer magnitude, and the surrounding context plays a pivotal role in why some cosmic occurrences leave a lasting imprint on our collective consciousness, while others quietly fade away. Astronomers are not only witnesses to these extraordinary events, but also sophisticated detectives using an arsenal of advanced tools to unravel the mysteries of the universe. One of the most essential methods they use is the observation of light from distant celestial bodies. Light, traveling across the vast expanse of space, takes time to reach us, and by measuring this delay, astronomers can pinpoint when an event took place. This process allows them to witness and analyze cosmic phenomena, such as supernova explosions or the dramatic merging of black holes, which can occur millions or even billions of light years away. These events are observable only because light, in its journey across the universe, carries with it clues that lead scientists to the moment of occurrence. However, light alone does not tell the entire story. To gain a deeper understanding of cosmic phenomena, astronomers rely on an array of instruments designed to capture different forms of electromagnetic radiation. These include radio waves, infrared, ultraviolet, and X-rays. Each of these wavelengths offers a unique perspective on the events unfolding in distant reaches of space. Visible light, for example, can reveal the brightness and color of stars, giving clues about their age, size, and composition. On the other hand, X-ray observations can shed light on the high-energy processes that occur during intense events like gamma-ray bursts, where the energy released is so powerful it can outshine entire galaxies. By combining data from these various wavelengths, astronomers can begin to assemble a more complete and nuanced understanding of cosmic events. This multidimensional approach allows them to piece together the puzzle of the universe, providing a clearer and more comprehensive picture of what is occurring in the farthest reaches of space. Another critical factor in understanding the timing of cosmic events is the periodicity of certain celestial objects. Some objects, like pulsars and variable stars, emit light in regular, predictable patterns, effectively acting as cosmic clocks. By monitoring these rhythmic pulses, astronomers can not only track the passage of time in the universe, but also predict future events with remarkable precision. These cosmic clocks enable them to correlate past events with future ones, revealing an intricate dance of celestial mechanics that governs the life cycle of stars, black holes, and galaxies. In the grand scheme, the timing of these cosmic events isn't just a matter of curiosity. It's a key to unlocking the deeper workings of the universe. By studying these cycles and the phenomena they mark, scientists can gain insights into the fundamental forces at play across vast cosmic distances. The precise understanding of celestial timing helps astronomers make accurate predictions about future events and provides a clearer framework for exploring the vast expanse of space, from the birth of stars to the death of galaxies. It is through this dynamic interplay of light, timing, and technological innovation that we continue to uncover the vast and awe-inspiring story of the universe. Computer simulations have increasingly become an indispensable tool in modern astronomy, providing an essential bridge between theory and observation. These advanced models allow astronomers to simulate cosmic events based on well-established physical laws, offering the means to predict celestial phenomena with remarkable accuracy. By comparing these simulations with real-world observational data, scientists are able to refine their understanding of the universe. This synergy between what we observe in the night sky and the models we create to interpret these observations helps us craft a more detailed and precise timeline of the universe's awe-inspiring history. Throughout the annals of scientific discovery, numerous cosmic events once hidden from our view have dramatically reshaped our understanding of the cosmos. One of the most profound of these revelations came with the discovery of gamma-ray bursts, first detected in the late 20th century. These high-energy explosions are so powerful that they can release more energy in mere seconds than the sun will emit over its entire lifespan. Initially mistaken for secret nuclear tests during the Cold War, these bursts were later traced back to distant galaxies. What made them even more intriguing was the realization that they are often the result of the catastrophic collapse of massive stars, creating some of the most energetic phenomena in the universe. Another monumental breakthrough came with the detection of cosmic microwave background, CMB, radiation, which serves as a faint but crucial relic from the Big Bang itself. This ubiquitous glow of heat, spread across the entire universe, was first discovered in 1965 by radio astronomers Arno Penzias and Robert Wilson, who had no idea that they had stumbled upon one of the most critical pieces of evidence confirming the Big Bang theory. The CMB's discovery provided the first direct observational proof of the universe's violent and fiery birth, offering valuable insights into its subsequent expansion and evolution over billions of years. The story of how we've come to understand supernovae, too, is one of gradual discovery. In the late 19th century, the phenomenon of a Type 1a supernova was first observed. These stellar explosions, once a curiosity, were later recognized as essential tools for measuring cosmic distances. Their consistent brightness made them reliable standard candles, helping astronomers gauge the vast distances between galaxies. This breakthrough led to a revolutionary realization in the late 20th century. The universe was expanding at an accelerating rate. This observation, in turn, gave birth to the theory of dark energy, a mysterious force driving the accelerated expansion, and forever altered our understanding of the cosmos. In 2015, another landmark discovery further deepened our cosmic knowledge. Gravitational waves, first predicted by Albert Einstein a century earlier, as part of his general theory of relativity, were finally detected by the Laser Interferometer Gravitational Wave Observatory, LIGO. These ripples in space-time, caused by the collision of massive objects like black holes, offered an entirely new way of observing the universe. With gravitational waves, scientists could now hear the universe in a way that was previously impossible, providing fresh insights into phenomena that had long been beyond our reach. Each of these milestones, once dismissed or undetected, has not only advanced our scientific knowledge, but has also ignited an insatiable curiosity about the universe's many mysteries. The more we uncover, the more we realize how much there is yet to understand. Cosmic events, it seems, are as powerful in their potential to inspire as they are in their ability to alter the very fabric of our reality. Some of these cosmic phenomena, though distant in space and time, have profound implications for life here on Earth. Solar flares, for instance, are bursts of radiation emitted by the sun. While typically a regular part of our star's activity, these flares can have significant impacts on Earth, disrupting satellite communications, navigation systems, and even power grids. In extreme cases, particularly strong solar flares can endanger astronauts in space, highlighting the delicate balance between technological advancement and the uncontrollable forces of nature. Asteroid impacts, too, carry the potential for catastrophic consequences. One of the most famous examples is the event that occurred around 66 million years ago when a massive asteroid collided with Earth, The resulting explosion triggered widespread wildfires, tsunamis, and a nuclear winter effect, where dust and debris blocked sunlight for months, leading to a global collapse of ecosystems. This devastation, while obliterating the dinosaurs, ultimately paved the way for mammals and eventually humans to rise to dominance. Even the more subtle cosmic influences have been shown to impact life on Earth. Cosmic rays, high-energy particles originating from distant regions of the universe, have been found to affect the Earth's atmosphere, contributing to cloud formation and potentially influencing weather and climate patterns. Some researchers have even proposed that these cosmic rays may play a role in biological processes, such as DNA mutations, which could contribute to the evolution of species over geological timescales. The universe, it seems, is a dynamic and interconnected system, with events unfolding both far above and deep within the fabric of space. From the invisible forces of dark energy to the explosive deaths of stars, our understanding of the cosmos has been shaped by each discovery. Some planned, others serendipitous. As technology continues to evolve and our methods of observation grow ever more sophisticated, we can only imagine the new cosmic revelations that await us. The movement of celestial bodies and cosmic events have far-reaching effects on Earth, influencing its long-term climate and the very fabric of life itself. These cosmic phenomena, from the eruption of supernovae to the intricate dance of the solar and lunar cycles, shape the atmosphere, the ecosystems, and even the geophysical conditions of our planet, in ways we are only beginning to fully comprehend. Supernova explosions, for instance, are cataclysmic events that release massive amounts of energy and radiation into the surrounding space. When a supernova occurs near a planet, its radiation can penetrate deep into the atmosphere, altering the chemical composition and possibly even disrupting the climate. These high-energy bursts impact not just the immediate environment, but they ripple out through the interstellar medium, affecting other bodies and planetary atmospheres across vast distances. By studying these celestial events, scientists can gain valuable insights not only into the origins of elements essential for life, but also into the vulnerabilities and potential resilience of life on Earth. The complexity of our existence is tied to this cosmic interconnectedness. We do not live in isolation, but are part of a dynamic and ever-changing universe. Each cosmic event, whether it's the radiation from a supernova or the subtle shifts in planetary positions, has the potential to alter the course of life here. These forces show us how deeply we are connected to the universe, emphasizing the need for continued exploration and understanding of the forces that shape both the cosmos and our very existence. One of the most visible demonstrations of this cosmic interconnectedness is the phenomenon of eclipses. These celestial events have captured the human imagination for millennia, offering rare and awe-inspiring views of the sky. Eclipses come in various forms, each offering a unique spectacle to the observer. A solar eclipse occurs when the moon passes directly between the Earth and the sun, casting a shadow across the Earth. The result is a dramatic darkening of the sky, ranging from a total eclipse where the sun is entirely obscured to a partial eclipse where only a portion of the sun is hidden. In an annular solar eclipse, the moon appears smaller than the sun, creating a striking ring of sunlight around the darkened lunar disk. These solar events are rare, and the path of totality, the narrow region where a total solar eclipse can be observed, makes such an event even more extraordinary. Only those within this path experience the eerie phenomenon of daytime turning into night for a brief period, an experience that is truly once in a lifetime for many. Lunar eclipses, on the other hand, occur when Earth passes between the sun and the moon, casting a shadow on the lunar surface. There are different types of lunar eclipses, each offering its own unique view. A total lunar eclipse causes the moon to take on a reddish hue, commonly known as a blood moon, due to the scattering of sunlight through Earth's atmosphere. Partial lunar eclipses cover only a portion of the moon, while penumbral lunar eclipses are subtler, with the moon passing through the outer shadow of Earth, resulting in a slight dimming that can be difficult to observe. Despite their varying intensity, lunar eclipses are more accessible than solar eclipses, visible to anyone on the night side of Earth, making them a more regular occurrence in the sky. These events do not occur randomly. They follow intricate cycles known as the Saros cycle, which repeats approximately every 18 years, 11 days, and some hours. This cycle leads to eclipses that mirror each other in geometry, offering a fascinating glimpse into the predictability of celestial mechanics. While we may not witness every eclipse from our location on Earth, these repeating cycles ensure that these events remain a captivating part of our astronomical rhythm. The rarest and most dramatic of these events are total solar eclipses. They are much more than just a celestial curiosity. They are an extraordinary scientific opportunity. During a total solar eclipse, when the moon completely obscures the sun's outer atmosphere, known as the corona, becomes visible. This phenomenon allows scientists to observe the sun's magnetic field, solar flares, and coronal mass ejections, events that can significantly affect space weather and the Earth's magnetic field. The temporary darkness and the drop in temperature that occur during the totality of a solar eclipse offer a unique environment for research, making it a highly anticipated event for both astronomers and physicists. This rare occurrence often sparks intense public interest, with observers traveling thousands of miles to be in the path of totality. The excitement surrounding these eclipses goes beyond their visual spectacle. It is the scientific mysteries they uncover that continue to fuel our curiosity. Total solar eclipses offer a rare opportunity to study phenomena that are typically hidden by the overwhelming brightness of the sun, making these events a highlight of the astronomical calendar. Lunar eclipses, while less dramatic, also hold significant scientific value. During a lunar eclipse, scientists have the rare chance to observe the Earth's atmosphere in action. The Earth's atmosphere filters sunlight that reaches the moon, scattering blue light and leaving behind a red hue. This provides valuable data on atmospheric composition, pollution levels, and how different atmospheric layers affect the passage of light. Additionally, lunar eclipses offer clues about Earth's weather patterns, as variations in atmospheric transparency can be linked to global climatic shifts. Both solar and lunar eclipses play crucial roles in advancing our understanding of celestial mechanics, the Earth's atmosphere, and the forces that govern our planet's climate. These events not only captivate the human imagination, but also offer scientists the tools to explore the fundamental forces that shape our world and the wider universe. The study of these phenomena allows us to better understand our place in the cosmos, not as passive observers, but as active participants in an interconnected and ever-evolving universe. Eclipses, in their majestic simplicity, have long captured the human imagination. Beyond their beauty, they have been pivotal in shaping our understanding of the universe, especially in the fields of gravity and motion. Throughout history, these celestial events have served as natural laboratories for testing and confirming complex scientific theories. Take, for instance, the solar eclipse. It has played a significant role in validating Albert Einstein's groundbreaking theory of general relativity. When researchers examined how stars seem to move during such an eclipse, their observations corroborated Einstein's predictions, reinforcing the foundations of modern physics. Yet in doing so, these studies also sparked profound questions about the very fabric of space and time. Eclipses, therefore, aren't just awe-inspiring displays, they are essential moments of cosmic revelation. Public interest in eclipses does not merely stem from their visual spectacle. These events often catalyze educational initiatives and citizen science projects, which engage people from all walks of life in the pursuit of knowledge. Amateurs and curious individuals alike contribute to data collection and observations during these occurrences, turning a scientific phenomenon into a collective endeavor. As a result, these collaborative efforts don't just enhance our understanding of the cosmos, they help cultivate a community of eager science enthusiasts excited to delve deeper into the universe's many mysteries. However, missing an eclipse can have far-reaching effects on the public's perception of our solar system. Eclipses offer rare and profound educational moments that bring complex astronomical concepts to life in an unforgettable way. During a solar eclipse, observers experience the delicate choreography of the Earth, Moon, and Sun firsthand. This vivid display ignites curiosity about the fundamental workings of the universe. Without this direct interaction with such an extraordinary event, many may remain unaware of the intricate mechanisms that govern the solar system, how the Earth orbits the Sun, the Moon's gravitational pull, and the subtle yet significant impact these dynamics have on our world. Perhaps most strikingly, a solar eclipse highlights the profound relationship between celestial bodies. The spectacle of the Sun being obscured by the Moon brings a unique opportunity to witness the hidden layers of the Sun's atmosphere, the corona, which is typically invisible to the naked eye. This extraordinary visual experience deepens our understanding of solar phenomena like solar flares, sunspots, and the Sun's influence on life on Earth. Without this dramatic moment, many might overlook the importance of studying the Sun's behavior, the cycles of solar activity, and its effects on Earth's climate and technology. But beyond mere observation, eclipses have historically spurred new avenues of scientific inquiry. As scientists gather data during these events, they deepen our understanding of the Sun's behavior and its impact on the Earth. The influx of interest generated by such a rare occurrence provides a unique opportunity for the public to engage with scientific concepts, which can sometimes seem distant and abstract. It is in these moments of collective wonder that the bond between the public and the scientific community grows stronger, inspiring curiosity and the desire to learn more about our place in the universe. The upcoming total solar eclipses promise to continue this legacy. However, not all of these eclipses will be visible to large populations. Take, for example, the total solar eclipse of April 8, 2024. This particular event will be visible across parts of North America, offering a breathtaking display for millions of people. Unlike many other eclipses, this one will pass over several major cities, including Dallas and Indianapolis, ensuring that the event will be accessible to a vast audience. It is a rare opportunity for millions to experience the awe and wonder of a total solar eclipse in their own backyards, offering a chance to connect with the cosmos and inspire the next generation of astronomers, scientists, and curious minds. In a world increasingly dominated by technology and screens, eclipses serve as a reminder of the vast and intricate beauty of the natural world, encouraging us to look up and wonder at the mysteries of the universe. The connection between the public and the scientific community, deepened during these moments, will continue to shape the future of space exploration and the pursuit of knowledge. Eclipses, as fleeting and rare as they are, remain one of the most powerful tools we have to inspire, educate, and unite in our shared journey through the cosmos. On the 30th of April, 2023, a rare celestial event will unfold, but for many, it will remain hidden from view. This event is a solar eclipse, one of the kind that will pass through a path of totality so remote that only a few will experience the thrilling darkening of the sky. The eclipse's path will primarily be visible from the southern reaches of South America and parts of Antarctica, leaving the vast majority of the world's population unable to witness this phenomenon. Those fortunate enough to be within the narrow band of the eclipse's path will have only a limited opportunity to observe this awe-inspiring spectacle. However, simply being in the right place is not enough. Viewing conditions are essential to ensure a clear view of the eclipse. Cloud cover, atmospheric conditions, and geographic isolation can all drastically affect one's ability to see the event. Even if an eclipse technically occurs nearby, heavy clouds or unfavorable weather can render it virtually invisible. In certain locations, remote areas with frequent inclement weather might make these celestial treasures impossible to observe, despite their cosmic proximity. As such, total solar eclipses remain elusive phenomena, rare treasures that pass unnoticed by many in major urban centers. The allure of these events is undeniable. Solar eclipse enthusiasts often embark on long journeys, seeking locations along the eclipse's path that promise clearer skies. Much like the excitement that surrounds each upcoming eclipse, the quest for the next visible event continues to capture the imagination of both casual stargazers and seasoned skywatchers alike. The chase for the perfect view of a solar eclipse is more than just a matter of timing. It is a pursuit that connects humanity to the wonders of the universe. Similarly, meteor showers, which occur at specific times throughout the year, offer another cosmic event to enjoy. These showers are the result of comets and asteroids passing through the Earth's atmosphere, with the best viewing times typically occurring during the night. The most spectacular meteor activity usually happens between midnight and dawn when the sky is darkest, and the meteor showers reach their peak. Notable meteor showers, such as the Perseids in mid-August and the Geminids in mid-December, provide some of the most spectacular displays. To fully appreciate the beauty of a meteor shower, one must find a location far from the bright lights of the city. Away from street lamps and urban glare, the night sky unfolds in all its glory, offering the clearest view of these fleeting streaks of light. When observing, it is important to let your eyes adjust to the darkness, as this will increase your chances of spotting meteors as they streak across the sky. These meteors, which travel at speeds exceeding 20 meters per second, often leave bright trails that last only a moment before disappearing. The sheer speed at which they burn through our atmosphere creates a brief, beautiful spectacle. Different meteor showers exhibit distinct characteristics. The Perseids, for example, are known for producing bright, colorful meteors, often in shades of green and red, while the Geminids tend to display a unique density with meteors scattered across the sky at varying brightness levels. Occasionally, you may be fortunate enough to witness a fireball, a particularly bright meteor visible even during the daytime. These fireballs stand out among the other meteors, offering a dramatic and unforgettable moment in the sky. Meteor showers hold a unique thrill, not just because of their beauty, but because of the anticipation they create. Each meteor is a tiny piece of space debris entering our atmosphere and burning up due to the intense friction it experiences. As you watch, it's easy to feel a connection with the distant past, for each shooting star is a remnant of our solar system's origins, a glimpse into the early stages of our cosmic neighborhood. These meteors are fragments of comets and asteroids that have traveled across the solar system, leaving a trail of tiny particles behind them. When a comet approaches the sun, it begins to heat up, releasing gas and dust into space. This process, known as outgassing, forms a glowing halo around the comet. As the comet continues on its orbit, it leaves a trail of these tiny particles in its wake. Once Earth passes through these trails, usually at specific times of the year, the particles enter our atmosphere at incredibly high speeds, burning up upon contact and creating the bright streaks we see as meteors. Not all meteor showers are equal in intensity. The number of meteors visible during the peak of a shower is largely determined by the density of the debris trail, which can vary significantly from one comet to another. Some comets release larger amounts of dust or were particularly active in the past, leading to more intense meteor displays. In these cases, the shower can be extraordinary, with dozens or even hundreds of meteors visible in just 1 hour. In essence, whether you're watching a total solar eclipse or a meteor shower, each event serves as a reminder of the vastness of the universe and our connection to it. While these celestial phenomena are fleeting, their beauty and mystery leave an indelible mark on all who witness them, creating memories that last a lifetime. Meteor showers, those captivating displays of light that streak across our night sky, are much more than just fleeting moments of beauty. They are cosmic events that invite awe and wonder as fragments of ancient celestial bodies enter Earth's atmosphere and burn up, creating a spectacle of brilliance. But these showers, while universally fascinating, vary in intensity and grandeur based on several key factors, ranging from the angle at which Earth intersects the debris trail to the nature of the celestial bodies that left the particles behind. The speed at which Earth intersects a debris stream can significantly influence the intensity of the meteor shower. When the planet enters the trail at a steep angle, it sweeps through a greater number of particles, resulting in a more spectacular visual display. On the other hand, a shallow angle may cause Earth to pass through a thinner section of the debris trail, leading to a more modest shower. The Perseids and the Geminids, two of the most well-known and breathtaking meteor showers, are often the result of both favorable conditions and dense debris fields. These showers benefit from rich remnants left by their parent bodies, along with clear, dark skies that allow their beauty to truly shine. However, the unpredictability of meteor showers is one of the things that adds to their charm. Even minor showers can sometimes surprise observers with bursts of intense activity, known as meteor outbursts. These outbursts occur due to variations within the debris trail, where certain regions might hold more particles than others, leading to dramatic bursts of activity. It's these irregularities and the constant motion of the cosmos that remind us of the dynamic nature of space, where remnants of ancient celestial bodies continue to shape the events we witness from Earth. The trails of debris that give birth to meteor showers are more than just a spectacle. They are relics of comets and asteroids that have long since passed, leaving behind fleeting moments of brilliance for us to admire. The intensity and visual grandeur of meteor showers depend largely on the composition of the debris trail, which in turn is influenced by the parent body. Most meteor showers occur when Earth passes through the debris left behind by comets or asteroids. As the Earth follows its orbital path, particles of dust and gravel traveling at speeds of up to tens of kilometers per second enter our atmosphere. The friction from this rapid entry causes these particles to burn up, creating the streaks of light we see as meteors. The density of the debris trail plays a crucial role in determining the number and brightness of the meteors. A denser trail will produce a higher number of meteors in a shorter period, making for a more spectacular show. For example, the Perseid meteor shower, which peaks every August, is renowned for producing bright, colorful meteors. This brilliance can be attributed to its origin, the debris left behind by Comet Swift-Tuttle, which has a substantial and dense trail of particles. When Earth intersects this dense region, observers are treated to a higher frequency of meteors, often filling the sky with vivid streaks of light. In contrast, meteor showers from less prolific parent bodies, such as the Eta Aquariids, which are associated with Halley's Comet, tend to produce smaller, less impressive showers. While these showers can still be beautiful, they are often not as visually striking or as frequent as the Perseids. Another factor that can enhance the visual spectacle of a meteor shower is the nature of the parent body's orbit. Comets, in particular, can release more debris when their orbits bring them closer to the Sun. As the icy comet approaches the Sun, its ice heats up, sublimates, and creates a larger cloud of particles. This process, known as outgassing, leads to the formation of a richer debris trail, which can result in more meteors during a shower. The positioning of the comet in its orbit is critical in determining the intensity of the meteor display. Yet, perhaps one of the most important factors influencing the quality of a meteor shower is the timing of the event. Clear skies, minimal light pollution, and a well-timed observation window can turn an ordinary meteor shower into an extraordinary event. During such optimal conditions, meteor storms can occur, where hundreds or even thousands of meteors light up the sky each hour. These rare meteor storms, such as the Leonids, are some of the most anticipated astronomical events, as they only occur in certain years when the Earth passes through particularly dense sections of the debris trail. Meteor showers have long captured the imaginations of people across the globe. Their beauty and unpredictability inspire wonder, and many cultures have associated these celestial phenomena with various myths, legends, and stories. One of the most famous meteor showers in history was the Leonid shower, which reached its peak in the late 19th and early 20th centuries. During its peak in 1833, the Leonids produced thousands of meteors every hour, creating a stunning display that could be seen across North America. This event was so spectacular that it drew large crowds of people who gathered to witness the celestial show, solidifying the connection between human experience and the cosmos. The Perseid meteor shower, which has been observed for centuries, is another iconic event in the world of meteor showers. This particular shower is linked to Comet Swift-Tuttle, and its particles have been lighting up the night sky every August for generations. The Perseids gained additional fame in the early 20th century when the shower produced an exceptionally high number of meteors, further cementing its place as one of the most anticipated annual events. Its bright and colorful meteors have made it a summer favorite, often prompting families and friends to spend nights outdoors, watching the sky in search of falling stars. The Geminid meteor shower, though first recorded in the mid-19th century, has only recently gained significant attention as one of the most impressive meteor showers. Occurring every December, the Geminids have grown in visibility over time, becoming one of the best meteor showers to observe. What sets the Geminids apart from others is their unique origin. Rather than coming from a comet, the Geminids are believed to originate from an asteroid, 3200 Phaethon. This rocky object sheds particles that create the stunning meteors visible in the shower, making the Geminids a fascinating exception in the world of meteor showers. Ultimately, meteor showers remind us of the vast and ever-changing nature of the universe. They are more than just spectacular light shows. They are the remnants of cosmic history, lighting up the night sky for all to witness. Whether it's the dense trails left behind by Comet Swift-Tuttle, the rare meteor storms of the Leonids, or the unique origins of the Geminids, each meteor shower tells a story of motion, time, and beauty. The Draconid meteor shower, renowned for its historical significance, has become a symbol of the awe-inspiring unpredictability of celestial events. Particularly memorable were its remarkable displays in the early 2000s, when the meteors originating from the dust trail left by Comet Giacobini-Zinner delivered some of the most astonishing bursts of activity on record. Typically, the Draconids are known for their relatively quiet shows, with only mild flares of activity punctuating the night sky. But on occasion, they have completely surprised observers, producing brief yet breathtaking displays that remind us how the universe still holds many mysteries and forces beyond our comprehension. Such meteoric events, unexpected and fleeting as they may be, speak to something fundamental about the cosmos, its ability to engage our curiosity and evoke a deep sense of wonder. However, this connection to the stars is not always so easily realized. Light pollution, a growing issue in urban and suburban areas around the world, has severely diminished our ability to witness these celestial phenomena in their full glory. As artificial light floods the night sky, the faint, glowing trails of meteors become almost impossible to detect, lost to the overpowering shine of streetlights, billboards, and brightly lit buildings. This pervasive glow diminishes the night's natural splendor, drowning out the subtle beauty of the stars and the quick streaks of meteors. When we step into an environment where light pollution is at its worst, our eyes struggle to adjust to the darkness. The natural adaptation that allows us to see in low-light conditions is impaired, making it difficult to discern even the most brilliant meteor streaks. For those hoping to witness a meteor shower, optimal viewing requires escaping the haze of artificial lights and finding a location far removed from city or suburban areas. In a dark, clear sky, the human eye can gradually become more sensitive to dim light, revealing meteors streaking across the heavens. Unfortunately, under light-polluted skies, this sensitivity is diminished, and the number of visible meteors during peak events can drop dramatically. While ideal conditions might offer an astounding 100 meteors per hour during an active shower, light pollution can reduce the count to just a few, or in some cases prevent an observer from seeing anything at all. This stark difference between what actually happens in the sky and what is visible to the naked eye highlights a troubling gap. Many people remain completely unaware of just how magnificent meteor showers can be. The impact of light pollution is not merely a matter of diminished visibility. It extends deeper, affecting our very relationship with the cosmos. Meteor showers have captivated humanity for millennia, serving as celestial messengers of cosmic events happening millions of miles away. They connect us to a vast universe, one filled with phenomena that occur on scales far beyond our everyday experience. When artificial lights obscure this connection, it alters not only how we experience the universe, but also how we appreciate it. The meteors that once inspired awe and wonder become little more than a fleeting memory, hidden from view by the glow of modern life. Efforts to mitigate light pollution can restore our connection to the night sky. Simple measures such as installing better shields on outdoor lights and raising awareness about the importance of dark skies can make a significant difference. These efforts not only help preserve the natural beauty of the night sky, but also rekindle our sense of wonder and curiosity, reigniting a deeper connection with the universe. The restoration of the night sky is an invitation to rediscover our place in the cosmos. Beyond meteor showers, the alignment of planets is another astronomical event that draws attention and ignites curiosity. A planetary alignment occurs when two or more planets appear to line up in the sky, creating a stunning visual display for those watching from Earth. These alignments, although rare, offer a chance to witness the relative positions of planets in our solar system, creating breathtaking visuals that have long fascinated stargazers and astronomers alike. From an astronomical perspective, these alignments are not only beautiful to behold, but also scientifically significant. They offer valuable opportunities to study the gravitational interactions between planets and to refine our understanding of their orbits over time. Historically, planetary alignments have held great cultural and symbolic importance. Ancient civilizations often regarded these alignments as omens or messages from the gods, imbued with meanings and prophecies that could influence their lives and decisions. This blending of science and culture highlights the profound impact celestial events have on humanity. They do more than simply display the mechanics of the cosmos. They inspire stories, beliefs, and a sense of wonder that transcends time. In modern astronomy, planetary alignments remain important for a variety of reasons. They are used to refine models of planetary motion and improve our understanding of the solar system's dynamics. For amateur astronomers and the general public, these alignments serve as an invitation to look up at the night sky and reconnect with the wonders of the universe. These events provide a rare opportunity for the scientific community, educators, and curious citizens alike to come together in appreciation of the intricate mechanics of our solar system. Major planetary alignments, while infrequent, never fail to capture our imagination. These alignments occur when planets in our solar system appear to align in close proximity to one another within the sky, forming a celestial spectacle that can be seen from Earth. These events are typically classified into two types: conjunctions, where two planets seem to be very close together, and more expansive alignments that involve several planets appearing in the same area of the sky. Significant alignments involving 4 or more planets generally occur once every few years, offering a rare glimpse into the dynamic relationships between these distant worlds. These alignments, though fleeting, provide an unforgettable experience, one that reminds us of the vast, interconnected dance of the planets and the unyielding curiosity that drives us to explore the unknown. As long as we continue to look up and wonder, the mysteries of the cosmos will remain ever present, inviting us to uncover new knowledge and gain a deeper understanding of the universe we inhabit. Planetary alignments are awe-inspiring events that stir both scientific curiosity and cultural fascination. While these celestial gatherings can vary in frequency, the timing and nature of these occurrences are intricately tied to the specific planets involved and their individual orbits. For instance, one of the most talked about alignments in recent years was the Grand Conjunction of December 2020, when Jupiter and Saturn came into an incredibly close alignment. As these two massive gas giants crossed paths in the night sky, their bright, synchronized display captured the imagination of millions. This rare spectacle was not just a visual wonder, but also an event that sparked global discussions, given its infrequency and historical significance. Looking ahead, the next major alignment is expected in 2030, and it promises to be a thrilling spectacle. During this alignment, 5 planets will be visible to the naked eye. Enthusiasts and casual skywatchers alike will have the rare opportunity to witness this stunning display, which could become a hallmark moment for astronomers and stargazers. Such events serve as a reminder of the wonders of our solar system and encourage people to pause, step outside, and gaze up at the vast expanse of the night sky, creating a shared sense of wonder and anticipation. However, the excitement surrounding these alignments goes beyond just the visual spectacle. In fact, planetary alignments are more than just a dazzling show. They can trigger a series of fascinating astronomical phenomena. One of the most intriguing aspects is the gravitational influence that these aligned planets exert on each other. When the planets line up, their gravitational forces can subtly affect one another, and this can extend to Earth, resulting in minor yet fascinating changes in tidal forces. These variations can influence ocean tides, and in some cases, they may even have a slight impact on geological activity, though these effects tend to be subtle and imperceptible in daily life. Nevertheless, the underlying cosmic interactions are an incredible reminder of how deeply connected our planet is to the celestial bodies that share our solar system. Alongside these gravitational effects, planetary alignments also create dramatic visual phenomena. When multiple planets align, they often appear in close proximity to one another in the night sky, creating a breathtaking spectacle that is far more striking than seeing individual planets scattered across the heavens. It's a celestial parade, with the planets appearing to move in synchrony, offering a rare unified display that captures the attention of both seasoned astronomers and casual skywatchers alike. The excitement builds as these alignments unfold, drawing observers into a deeper appreciation of the grandeur of the universe. Moreover, these alignments provide exceptional opportunities for scientific observation. During these rare events, astronomers can take advantage of the alignment to study the planets involved in greater detail. By using advanced techniques such as spectroscopy, scientists are able to analyze the light emitted or absorbed by the planets, which reveals important insights into their compositions, atmospheric conditions, and even their weather systems. Alignments thus offer natural laboratories for research, allowing us to expand our understanding of planetary atmospheres and climates, and providing clues about conditions on distant worlds. The cultural significance of planetary alignments cannot be understated either. For millennia, these events have been woven into the myths and histories of civilizations across the globe. From the Mayans to the Babylonians, ancient peoples closely observed these celestial phenomena, often associating them with profound earthly events or omens. These alignments, once seen as mysterious messages from the heavens, have deeply influenced human narratives about the cosmos. Even today, planetary alignments continue to inspire awe, sparking imaginations and connecting us to stories that date back to the dawn of human civilization. Advancements in technology have played a crucial role in enhancing our ability to observe these celestial alignments with greater precision. Powerful ground-based telescopes and space observatories have revolutionized our understanding of distant phenomena. Thanks to developments in adaptive optics, astronomers are now able to correct the distortions caused by Earth's atmosphere, providing clearer and sharper images of celestial objects, images that were once the domain of space-based telescopes. This breakthrough allows scientists to study the fine details of planetary atmospheres and surface features, revealing information that would otherwise be impossible to obtain. Furthermore, the integration of artificial intelligence and machine learning has significantly improved the efficiency of astronomical observations. With the vast amounts of data generated by modern telescopes, AI algorithms now help astronomers sift through enormous datasets with speed and accuracy, identifying alignments and other celestial events that may have gone unnoticed by the human eye. These automated systems can detect subtle patterns in the data, accelerating the process of predicting future alignments and enhancing our ability to monitor the dynamic and ever-changing universe. As we continue to look up at the night sky, the celestial alignments that occur with such rare frequency will remain a source of wonder, scientific exploration, and cultural significance. Each alignment, whether it brings with it a gravitational impact or a breathtaking visual display, serves as a reminder of the complexity and beauty of the universe we inhabit. For those who are fortunate enough to witness these events, the sense of connection to something far greater than ourselves is palpable. A reminder that though we may live on a small planet in a vast cosmos, we are, in some way, part of a much grander story. Advancements in radio astronomy have unlocked a new frontier of cosmic discovery, allowing scientists to detect signals from celestial events that would otherwise remain hidden from view in optical wavelengths. These signals offer complementary insights into the universe, providing a deeper understanding of the vast and complex interactions between celestial bodies at various stages of their evolution. As technology continues to advance, our ability to observe and comprehend the intricacies of these cosmic phenomena becomes increasingly sophisticated. With every step forward, we are invited to explore the mysteries of the universe more profoundly, drawing closer to the hidden forces that shape the cosmos. Yet, despite the growing capabilities of modern science, the phenomena of planetary alignments remain elusive to many. Several factors contribute to this subtle invisibility. First and foremost, many people lack the knowledge or interest in astronomy to recognize these celestial events when they occur. Planetary alignments often involve planets that are either dim or positioned far away, making them difficult to distinguish from the brilliance of stars and other more prominent celestial bodies. Without a solid understanding of the night sky or the necessary tools to observe it, these awe-inspiring occurrences often go unnoticed. Furthermore, the timing of these alignments presents its own challenges. Alignments don't always occur at times that are convenient for observation. At times, the planets involved are low on the horizon, hidden behind trees, buildings, or mountains. In some cases, these events happen during the day, when the bright light of the sun makes it impossible to observe the planets without specialized equipment. Even though these celestial phenomena unfold above us, most people's daily routines and responsibilities often mean stargazing takes a back seat. Thus, while planetary alignments occur on a regular basis, they remain largely ignored or overlooked by the public. The visibility of these alignments is further complicated by their frequency and the varying perspectives from which they can be viewed. While alignments might happen every few years, the location of the observer plays a significant role in whether or not the event can be seen. A dazzling display visible from one region might be completely obscured in another, creating a disparity in awareness among different populations. The global variation in visibility can make it difficult for individuals to truly appreciate the beauty and significance of these events. Compounding this issue is the increasing distraction of modern life. With the rise of technology and entertainment, fewer individuals take the time to look up at the night sky. The allure of constant access to digital devices and media leaves little room for stargazing. As a result, these spectacular cosmic alignments, which hold deep scientific and philosophical value, remain largely hidden in plain sight, obscured not by clouds or cosmic distance, but by the relentless pace of modern life and the difficulty of observation. Turning our attention to one of the most dramatic events in the universe, the supernova, this explosive phenomenon occurs when a massive star reaches the catastrophic end of its life cycle. Supernovae are born when a star exhausts its nuclear fuel. There are two primary types of supernova, Type 1 and Type 2. Type 1 supernovae happen in binary star systems, where a white dwarf star gathers matter from a companion star until it reaches a critical mass. This mass triggers a catastrophic explosion. In contrast, Type 2 supernovae occur in the cores of massive stars, typically those with more than 8 times the mass of our Sun. As these stars deplete their nuclear fuel, their cores collapse under the force of gravity, triggering a dramatic explosion that sends the star's outer layers hurtling into space. The implications of supernovae for the cosmos are profound and far-reaching. These explosive events are among the primary sources of heavy elements, such as iron and nickel, that are essential for the formation of the stars and planets we see today. As a supernova detonates, it disperses these elements into the surrounding interstellar medium, enriching the cosmic material that will eventually condense to form new generations of stars and planets. This process is part of the larger cycle of stellar life, death, and rebirth, illustrating the dynamic and ever-evolving nature of the universe. Beyond their role in synthesizing elements, supernovae also play a crucial role in shaping the dynamics of galaxies. The immense energy released in these explosions can compress nearby clouds of gas and dust, triggering the birth of new stars in regions that were previously too diffuse. In some cases, the shock waves produced by supernovae can even disrupt existing star systems, influencing the orbits of nearby celestial bodies. These interactions play a key role in the ongoing formation of galaxies, contributing to the structure and composition of the universe itself. In sum, while many of the universe's most fascinating phenomena remain hidden from our everyday view, they are an integral part of the cosmic dance. Advances in technology continue to bring these wonders into sharper focus, enabling us to observe and understand the forces that govern the cosmos. However, the challenge remains for us to recognize and appreciate these celestial events, as they are often obscured by our limited knowledge, daily distractions, and the vastness of space itself. Supernovae are among the most awe-inspiring and powerful events in the universe, serving as both cosmic phenomena and vital tools for astronomers. These stellar explosions, particularly the Type 1 supernovae, are known as standard candles. This term refers to their ability to provide consistent luminosity, making them invaluable for measuring vast cosmic distances. By comparing the known brightness of these supernovae with how dim they appear from Earth, scientists can calculate the distance between us and these distant objects, offering a glimpse into the expansive universe that stretches far beyond our grasp. When a supernova occurs, it is a cosmic spectacle of extraordinary proportions. A single star's collapse and subsequent explosion can release an energy output so immense that it briefly outshines an entire galaxy. The burst of light can become brighter than 50 billion suns combined for a short period, illuminating vast stretches of space and making it visible across immense distances. This immense brightness contrasts sharply with the steady glow of a typical galaxy, which, although made up of billions of stars, radiates a more uniform and less dramatic light. In some instances, if a supernova erupts in a neighboring galaxy, its brilliance can dominate the night sky, far outshining the faint, twinkling lights of the individual stars that make up the galaxy. Such an event not only captivates the imagination, but also provides invaluable scientific insights. The predictable nature of a supernova's brightness allows astronomers to use it as a marker for measuring the scale of the cosmos. By knowing the inherent luminosity of a particular type of supernova, scientists can determine how far away it is based on how dim it appears from Earth. The fleeting nature of a supernova's luminosity, lasting only a few weeks to months, presents a stark contrast to the eternal glow of a galaxy. While the light from galaxies endures indefinitely, the brilliance of a supernova is temporary, marking a moment in the life cycle of a star. This temporary burst of energy is a vivid reminder of the ever-changing processes shaping the universe, including the birth, life, and death of celestial bodies. Throughout history, several supernovae have left a lasting imprint on our understanding of the cosmos, offering both awe and significant scientific revelations. One of the earliest recorded supernovae, known as SN 1000, was observed by Chinese astronomers in the year 1000. This supernova, which remained visible for nearly 800 days, was an early opportunity to study stellar evolution and the nature of cosmic explosions. Another important event came in 1604, when Kepler's supernova was observed. Named after the renowned astronomer Johannes Kepler, this supernova was remarkable not only for its brightness, outshining every star in the night sky, but also for Kepler's meticulous observations, which helped lay the groundwork for modern studies of stellar explosions. The remnants of this supernova can still be seen today as the Kepler Nebula. In more recent times, two supernovae in particular have captured the attention of the scientific community: SN 1998 and SN 1993J, both of which provided crucial evidence for our understanding of stellar evolution and the expansion of the universe. The 1998 explosion, visible in the M83 galaxy, offered direct evidence for how certain stars transition into supernovae. This event also led to the discovery of the Type 2A supernova, a key marker for measuring cosmic distances. Such discoveries have revolutionized our understanding of the universe, confirming that it is not static, but rather expanding over time. These supernovae are not just celestial beacons, they are key indicators of the processes that govern our universe. Each explosion reveals a chapter in the life and death of stars, offering glimpses into the fundamental workings of the cosmos. They provide us with an understanding of how stars evolve, how they die, and how new stars and elements are born from these violent deaths. In the event that a supernova were to occur in a nearby galaxy, its impact on Earth would be profound, depending on the distance between the explosion and our planet. If such a catastrophic event were to occur within 20 light-years of Earth, the consequences could be severe. Supernovae release an enormous amount of energy, including high-energy radiation and particles. Despite Earth's protective atmosphere and magnetic field, this radiation could reach our planet, potentially disrupting our atmosphere and depleting the ozone layer. The ozone layer is essential for shielding life on Earth from harmful ultraviolet radiation, and its depletion could have dire consequences for terrestrial life. In addition to the potential environmental risks, the explosion of a nearby supernova could create a spectacular visual display. The light from such an event would be visible across the night sky, offering astronomers a rare opportunity to study the remnants of a dying star. This bright illumination could also alter the behavior of nocturnal animals, as well as humans, disrupting the natural rhythm of night and day. For a period of weeks or months, the supernova would provide an extraordinary, if temporary, light show, revealing the dynamic forces shaping the universe. In conclusion, supernovae are much more than just brilliant flashes in the cosmos. They are essential to our understanding of the universe's structure and evolution. These stellar explosions provide a way to measure cosmic distances, track the life cycles of stars, and explore the fundamental laws that govern the cosmos. Whether they light up the night sky or provide crucial data about the expanding universe, supernovae continue to shape our understanding of the universe, leaving an indelible mark on both science and the imagination. However, it is crucial to recognize that most supernovae occur in distant galaxies, millions of light years away from Earth. These spectacular events, while captivating in their enormity, are exceptionally rare. Though they can have a dramatic influence on their surroundings, they are highly unlikely to pose any direct threat to our planet. The vastness of the universe and the life cycles of stars continue to spark awe and wonder, inspiring an insatiable curiosity about the cosmos and our place within it. The advancements in technology over recent years have opened new frontiers in observing and understanding these explosive phenomena. One of the most significant breakthroughs is the enhancement of telescopes, particularly those designed to detect transient events, such as supernovae, that occur within our observable universe. These next-generation telescopes, equipped with high-resolution imaging sensors and the ability to scan vast areas of the night sky, can capture rapid changes in brightness. This allows astronomers to spot the initial flashes of a supernova shortly after it explodes, providing valuable early data on the event. In addition to these improvements, the integration of automated survey systems is revolutionizing our ability to monitor the universe. These systems, constantly scanning the sky, utilize complex algorithms to identify potential supernovae. Large-scale projects like the upcoming Large Synoptic Survey Telescope, LSST, aim to gather vast amounts of data across the sky, greatly increasing the likelihood of spotting supernovae in their infancy. By collecting real-time data, researchers can track the light curve of the explosion and analyze the chemical makeup of the remnants, helping to deepen our understanding of these powerful events. Space-based observatories also play a vital role in advancing our knowledge of supernova. The James Webb Space Telescope, JWST, with its remarkable ability to observe infrared wavelengths, provides unprecedented insights into the surrounding dust and gas of supernova remnants. These observations shed light on the conditions of the early universe and the processes that lead up to these stellar cataclysms. By studying these phenomena at various stages of cosmic evolution, we can begin to unravel the mysteries of star formation, evolution, and death. Furthermore, the field of spectroscopy has made great strides, offering another layer of understanding. Spectroscopy enables scientists to study the light emitted by distant supernovae, helping them determine the composition and physical processes at play during the explosion. This innovative method allows researchers to peer deeper into the mechanics of these cosmic events, offering a clearer picture of the complex interactions between matter, energy, and gravity. Looking ahead, the future of supernova observation is bound to expand our understanding of these dramatic cosmic occurrences. Not only will we learn more about the nature of supernovae themselves, but these discoveries will also deepen our knowledge of the universe as a whole, particularly in the areas of stellar evolution and galactic dynamics. These insights could have profound implications, reshaping our understanding of the cosmos on both a grand and intimate scale. At the heart of many of these processes lies one of the most fascinating and enigmatic objects in the universe, the black hole. A black hole is a region in space where gravity is so intense that nothing, no light, can escape its pull. These objects are born from the collapse of massive stars, which, after exhausting their nuclear fuel, collapse under the weight of their own gravity. The outer layers of the star are expelled in a spectacular supernova explosion, while the core implodes, forming a dense singularity that warps the very fabric of space-time. Black holes are categorized primarily by their mass. Stellar black holes, which are formed when individual massive stars collapse, typically have masses that range from a few times that of our sun to several tens of solar masses. Supermassive black holes, found at the centers of most galaxies, can contain millions or even billions of solar masses. A more mysterious class, intermediate black holes, may exist somewhere between the stellar and supermassive varieties, and they are believed to form through the merging of smaller black holes. These objects are associated with some of the most awe-inspiring phenomena in the universe. One such event is accretion, the process in which matter from a surrounding disk spirals into the black hole. As this matter accelerates toward the event horizon, it heats up to extreme temperatures, emitting intense X-rays and other forms of radiation detectable by advanced telescopes. These high-energy emissions are often accompanied by gamma-ray bursts, which are among the most powerful explosions observed in the universe. The study of black holes and the high-energy events surrounding them provides scientists with a unique opportunity to explore the limits of physics, particularly in the realm of gravity and quantum mechanics. These objects challenge our understanding of space-time and the fundamental forces that govern the universe. Each discovery brings us closer to unlocking the secrets of these enigmatic cosmic giants and in doing so, expands our knowledge of the very nature of existence itself. Black holes, one of the most enigmatic and powerful phenomena in the universe, can not only exist in isolation, but also collide and merge with one another. This rare and extraordinary occurrence has recently been detected through the observation of gravitational waves, ripples in the very fabric of space-time that reverberate across the cosmos. These waves offer a profound glimpse into the hidden nature of black holes, challenging long-held beliefs about gravity and expanding our understanding of the universe itself. As our ability to detect and study these cosmic events grows, so does our knowledge of black holes and the fundamental laws of physics that govern them. Despite their reputation for being invisible, black holes are detectable. They do not emit light, yet their presence is revealed through their immense gravitational influence on nearby objects. For example, in binary star systems, where a black hole shares space with a companion star, the black hole's gravity pulls matter from the star. This material forms an accretion disk, a swirling ring of gas and debris that spirals inward, gradually heating to extreme temperatures. The friction within this disk generates bright X-rays, which can be captured by sophisticated instruments that are specially designed for such tasks. In addition to this method, astronomers can infer the presence of a black hole by observing the movement of stars orbiting what appears to be an invisible object. When these stars show rapid and unexpected motion, it suggests the presence of a mass concentrated in a very small area. This is exactly how the existence of Sagittarius A, the supermassive black hole at the center of our own Milky Way galaxy, was confirmed. By tracking the orbits of nearby stars, scientists observed their erratic and rapid movements, providing undeniable evidence of a massive gravitational force in that region. Gravitational waves, too, have become essential tools in the detection of black holes. When black holes collide, they create massive disturbances in space-time, ripples that propagate outward through the cosmos. These waves travel at the speed of light, carrying with them information about the black holes involved in the collision. Information that can only be captured by advanced observatories like the Laser Interferometer Gravitational Wave Observatory, LIGO. Each detection of a black hole merger offers a wealth of data, revealing not just the existence of black holes, but their masses, spins, and other critical properties. These findings provide crucial insights into the dynamics of black hole mergers, which are among the most violent events in the universe. As technology continues to advance, the possibilities for further breakthroughs in black hole research grow exponentially. A landmark moment in this field came in 2019, when the Event Horizon Telescope, EHT, collaboration achieved an extraordinary milestone, the first ever image of a black hole's event horizon. This iconic image, captured at the center of the distant galaxy M87, provided visual proof of a black hole's existence, offering a tangible confirmation of theories that had been proposed for decades. For the first time, humanity could see the edge of a black hole, a boundary known as the event horizon, beyond which nothing, not even light, can escape. But even with these significant advancements, the journey into understanding black holes is far from complete. One of the most exciting recent developments is the discovery of intermediate mass black holes, objects that sit between stellar black holes, which form from the collapse of massive stars, and supermassive black holes, which reside at the centers of galaxies. These intermediate mass black holes are believed to be key players in understanding the formation of supermassive black holes. Their existence could help bridge the gap in our understanding of how black holes evolve over cosmic time and how they shape the galaxies that surround them. The detection of gravitational waves, beginning in 2015, has dramatically transformed our view of black holes and their role in the universe. These waves, generated by the collision of black holes, have opened a new window into the study of these mysterious objects. With each new detection, scientists are able to refine their models of black hole dynamics, uncovering more about their masses, spins, and how they merge. The groundbreaking work in this field is pushing the boundaries of astrophysics, offering a deeper understanding of the universe's most enigmatic phenomena. These discoveries are only the beginning. As we continue to develop more advanced observational tools and techniques, the mysteries of black holes will slowly unravel. The violent collisions, the unseen mergers, and the strange effects these invisible giants have on their surroundings are just a few of the many questions still waiting to be answered. Each new breakthrough brings us closer to understanding the true nature of these cosmic giants and their fundamental role in the universe's grand design. The study of black holes, particularly their voracious appetite for surrounding material known as accretion, has profoundly expanded our understanding of their role in the universe. For years, black holes were perceived as enigmatic cosmic vacuum cleaners, relentlessly devouring nearby stars and gas clouds. However, as observations have evolved, scientists have uncovered deeper insights into how these massive objects interact with the surrounding environment, including stars, gas clouds, and even entire galaxies. It turns out black holes are not just passive bystanders in the cosmos, but dynamic entities that shape and influence the formation of stars and the very evolution of galaxies themselves. One of the most fascinating discoveries has been the way black holes can influence star formation. While it was once thought that their powerful gravitational pull simply consumed everything in their path, it is now clear that black holes can also act as catalysts for the birth of new stars. As black holes feed on the surrounding gas and dust, they release enormous amounts of energy, which can trigger the compression of nearby clouds, ultimately leading to the formation of new stars. This paradoxical relationship between destruction and creation shows that black holes are not simply cosmic voids, but pivotal forces in the continuing cycle of stellar life and death. Perhaps one of the most groundbreaking observations in recent years is the way black holes interact when they come close to one another. When two black holes spiral toward each other, their massive gravitational fields interact in such a way that they create ripples in the fabric of space-time. These ripples, known as gravitational waves, travel outward through the universe at the speed of light. As the black holes lose energy in the form of these waves, they spiral closer until they eventually merge in a cataclysmic event that releases an incredible burst of energy. The collision of black holes is one of the most energetic events in the universe, and the resulting gravitational waves provide us with an unprecedented way to study the cosmos. Unlike traditional methods of observation that rely on electromagnetic radiation, such as visible light, X-rays, or radio waves, gravitational waves offer an entirely different perspective. They allow scientists to detect phenomena that are invisible to conventional telescopes, such as the merger of two black holes or the collision of neutron stars. These events often occur in regions where light is blocked by dense clouds of gas, or where the signals are simply too faint to detect through traditional means. What makes gravitational waves particularly exciting is that they provide a direct window into the properties of black holes, such as their mass, spin, and even their shape. Before this discovery, studying these properties was incredibly challenging, as they could not be measured through conventional electromagnetic observations. The first direct detection of gravitational waves in 2015 confirmed predictions made by Albert Einstein more than a century earlier in his general theory of relativity. This monumental achievement not only validated Einstein's theories, but also opened up a completely new field of astrophysical research, gravitational wave astronomy. The implications of this discovery are vast. Gravitational waves offer a unique method to probe the universe, shedding light on phenomena that were previously undetectable. They can reveal information about the early universe, helping us understand the conditions that prevailed moments after the Big Bang. They can also provide insights into the nature of gravity itself, offering new clues about how this fundamental force operates under extreme conditions. Moreover, gravitational waves give us a deeper understanding of the behavior of matter in the most violent environments imaginable, such as the mergers of black holes and neutron stars. As the technology behind gravitational wave detectors continues to advance, the potential for further breakthroughs in our understanding of the universe is enormous. And each new detection offers more clues about the cosmos, pushing the boundaries of what we know and how we know it. In fact, the discoveries made through gravitational wave astronomy have already begun to reveal an interconnected, more nuanced view of the universe, one where even the most extreme events leave a detectable signature in the very fabric of space-time. But the excitement doesn't stop there. The next wave of exploration is already underway, with missions like the James Webb Space Telescope, launched in late 2021, poised to further expand our understanding of black holes and their environments. Unlike traditional telescopes, which observe the universe primarily in visible light, the Webb telescope operates in the infrared spectrum, allowing it to peer through the dust and gas that often obscure black holes. This unprecedented capability will enable scientists to observe the regions surrounding black holes in new ways, revealing how these cosmic giants interact with and influence their galactic neighborhoods. Through this combination of gravitational wave detection and cutting-edge space telescopes, we are on the brink of a new era in astrophysics, one where black holes, once mysterious and remote, are now becoming integral to our understanding of the cosmos. With each discovery, we gain a deeper appreciation of how these enigmatic objects not only shape the universe, but are in many ways its architects, influencing the formation of stars, the evolution of galaxies, and the very structure of space-time itself. The journey to unravel the mysteries of black holes has only just begun, and as our tools and techniques evolve, so too will our understanding of these awe-inspiring cosmic forces. In the late 2020s, a groundbreaking mission is set to launch, the European Space Agency's Advanced Telescope for High-Energy Astrophysics, or ATHENA. This ambitious project aims to delve deep into the high-energy X-ray emissions produced by matter being devoured by black holes. By focusing on these X-rays, ATHENA will give scientists the tools to examine the enigmatic properties of black holes, as well as their profound influence on the evolution of galaxies. The mission promises to illuminate the intricate relationship between these cosmic giants and the very structure of the universe itself. Through ATHENA's eyes, researchers will explore how black holes interact with their surroundings, feeding off stellar remnants and gas clouds while distorting space-time. This research not only pushes the boundaries of our understanding of one of the most mysterious forces in the cosmos, but also provides insight into how black holes shape the formation and development of galaxies over billions of years. Ultimately, ATHENA aims to unlock the secrets of these dark, dense objects that are pivotal to the dynamics of the universe. Meanwhile, across the vast stretches of space, high-energy particles known as cosmic rays travel at nearly the speed of light. These cosmic particles, originating from distant supernovae and other violent astrophysical events, are primarily composed of protons, with smaller amounts of heavier ions and electrons mixed in. When these particles reach Earth, they do not simply pass by unnoticed. Instead, they collide with the atoms in Earth's atmosphere, generating cascading showers of secondary particles. This dramatic interaction produces a variety of radiation, including muons and neutrinos, which further contribute to the background radiation levels we experience on the surface of our planet. Most of these cosmic rays are deflected by Earth's magnetic field, but some manage to penetrate deep into the atmosphere, where they continue their journey of transformation. As they interact with the molecules in the air, they can ionize atoms, which in turn may influence atmospheric chemistry and even cloud formation. This ability to alter the composition of the atmosphere is far from trivial, as the intensity of cosmic rays can potentially impact Earth's climate. One of the more fascinating aspects of cosmic rays is their potential influence on climate patterns. Studies have suggested that fluctuations in cosmic ray intensity might play a role in cloud nucleation, the process by which water vapor condenses into droplets to form clouds. During periods of heightened cosmic ray activity, an increase in cloud cover could occur, possibly resulting in a cooling effect on Earth's climate. While this influence is relatively minor compared to other factors like greenhouse gas emissions or volcanic activity, it raises important questions about the ways in which cosmic phenomena can subtly influence our planet's environment. The activity of cosmic rays is not a constant. Instead, it can fluctuate dramatically depending on various astrophysical events. One of the most significant contributors to spikes in cosmic ray intensity are supernova explosions. These stellar cataclysms mark the explosive deaths of massive stars, sending shockwaves rippling through space. These shockwaves can accelerate particles to energies far beyond anything experienced on Earth, generating a burst of cosmic rays that travel across vast distances, impacting everything in their path. Another major source of increased cosmic ray activity comes from solar flares. These intense outbursts of radiation and energetic particles occur when the sun's magnetic field becomes highly disturbed. During these flares, the sun can release massive bursts of energy, with particles traveling toward Earth at incredible speeds. When solar flares coincide with periods of heightened solar activity, known as solar maxima, the increased energy can lead to a surge in cosmic ray interactions within Earth's atmosphere. In addition to direct cosmic ray activity, the interaction between cosmic rays and Earth's atmosphere also leads to the production of secondary particles. These interactions can amplify the cosmic ray flux, especially during geomagnetic storms. These storms, which are triggered by solar wind interacting with Earth's magnetic field, can enhance the number of cosmic rays reaching the surface, further complicating our understanding of their environmental impact. The study of cosmic rays and their effects on Earth's atmosphere continues to evolve as scientists seek to understand the subtle ways in which the cosmos influences life on Earth. The implications of these findings are far-reaching, not just for our understanding of the universe, but for our place within it. By continuing to study the high-energy particles that travel across the universe, we gain new insights into the forces that shape the very fabric of space and time. Through missions like Athena and the ongoing study of cosmic rays, humanity's quest to understand the universe is bound to yield more discoveries, revealing the interconnectedness of the cosmos and our home planet. Cosmic rays, high-energy particles from beyond our solar system, have long fascinated scientists for their potential to unlock the deepest mysteries of the universe. These particles, which travel through space at nearly the speed of light, serve as messengers from distant and powerful cosmic phenomena. Their study reveals not only the mechanics of their origins, but also the intricate workings of the universe itself. In particular, cosmic ray activity can be influenced by large-scale cosmic events, such as the collision of massive celestial bodies or the extreme environments surrounding black holes and neutron stars. The powerful gravitational forces and intense energy fields in these regions often produce elevated levels of cosmic rays, making them vital areas of study. Understanding how these cosmic rays are generated can provide scientists with key insights into the nature of these extraordinary objects and the broader dynamics of our universe. As these particles travel through space and eventually interact with Earth's atmosphere, they give scientists a unique window into the cosmic events that created them. By analyzing the secondary particles generated from these interactions, researchers can uncover critical information about the sources of cosmic rays, which range from supernovae and gamma-ray bursts to the enigmatic phenomena occurring near black holes. In essence, cosmic rays are more than just high-energy particles. They are vital clues that shed light on the violent and mysterious processes shaping the cosmos. The future of cosmic ray research holds great promise, driven by technological innovations and international collaborations. One of the most exciting developments in this field is the creation of increasingly sophisticated detection technologies, including both ground-based and space-based observatories. These observatories aim to detect cosmic rays with unprecedented precision, expanding our ability to study these particles across the full spectrum of energies and sources. One major initiative is the planned launch of space-based observatories. By positioning detectors above Earth's atmosphere, free from atmospheric interference, scientists will be able to capture cosmic rays in their purest form. These space missions, such as the upcoming space observatories, equipped with advanced telescopes and particle detectors, will allow researchers to study the high-energy particles that continuously bombard our planet from distant corners of the universe. At the same time, ground-based facilities are evolving to provide even greater sensitivity and coverage. Large-scale experiments, such as the Pierre Auger Observatory in Argentina, are expanding their networks of detectors, enabling researchers to track the paths of cosmic rays as they interact with the Earth's atmosphere. These observatories play a key role in unraveling the origins and behavior of these high-energy particles, pushing the boundaries of what we know about the universe. Moreover, advancements in data analysis and machine learning are accelerating research in the field of cosmic ray science. By harnessing the power of algorithms to process massive amounts of data, scientists can more efficiently identify patterns, anomalies, and potential sources of cosmic rays. This data-driven approach is proving essential as researchers piece together the complex puzzle of cosmic ray origins, energy profiles, and interactions with the atmosphere. International collaboration is another cornerstone of future cosmic ray research. Scientists across the globe are sharing data, resources, and findings to build more comprehensive models of cosmic ray behavior. With each new discovery, global research teams are developing a clearer understanding of how cosmic rays influence the universe around us, and in turn, how they can be used to explore the fundamental forces that govern the cosmos. Recent advancements in detector technology have also been pivotal in transforming our understanding of cosmic rays. Innovations in material science and detector design have enabled the creation of more sensitive instruments capable of detecting a broader range of cosmic ray events. One notable development is in the field of water Cherenkov detectors, which use large volumes of water to capture the faint light produced when a high-energy cosmic ray interacts with the water. These detectors are particularly adept at observing the extensive air showers generated by ultra-high-energy cosmic rays, offering an invaluable tool for cosmic ray research. Furthermore, satellite-based detectors have revolutionized cosmic ray science, providing unprecedented access to data about cosmic rays in space. Instruments like the Alpha Magnetic Spectrometer, AMS, have been instrumental in measuring the abundance and types of cosmic rays, offering new insights into their origins and the processes responsible for their acceleration. These spaceborne detectors, positioned in low Earth orbit, are free from atmospheric interference, enabling them to collect more accurate readings of cosmic rays' energies, trajectories, and particle types. Another area of progress is the development of particle accelerators and new detection methods, such as muon imaging. These techniques enable scientists to study cosmic rays by detecting secondary particles generated when cosmic rays collide with the Earth's atmosphere. By imaging deep underground or measuring phenomena caused by cosmic rays passing through materials, researchers are uncovering new insights into the interactions and nature of these high-energy particles. The integration of advanced computing technologies has further transformed cosmic ray research. Machine learning algorithms now play a critical role in analyzing vast quantities of data more efficiently than ever before. These algorithms can identify subtle patterns and anomalies in the data, opening new avenues for research and accelerating our understanding of cosmic rays. As a result, scientists are making significant strides toward unraveling the mysteries of cosmic ray origins, their behavior, and their role in the broader context of the universe. In conclusion, cosmic rays are much more than high-energy particles. They are messengers from distant corners of the universe, carrying with them valuable information about the most powerful and enigmatic phenomena in existence. With each technological advancement, Each international collaboration and each new research breakthrough, scientists are coming closer to answering some of the most profound questions about the universe. The study of cosmic rays not only enriches our understanding of the cosmos, but also brings us closer to unlocking the fundamental forces that shape the universe itself. Cosmic rays are enigmatic messengers from the universe, traveling across vast expanses of space, each carrying with them extraordinary energy levels that exceed the power produced by even the most advanced terrestrial accelerators. These particles, with energies often surpassing 10 to the power of 26 electron volts, offer scientists a rare glimpse into the heart of particle physics. Their study pushes the boundaries of our understanding of the universe, forcing us to reevaluate long-established theories in light of their extreme properties. Unlike any conditions found on Earth, cosmic rays expose our models of the universe to environments that cannot be replicated in a laboratory, revealing new insights about the fundamental forces at work in the cosmos. But these rays do not travel through space unimpeded. They interact with the magnetic fields that fill the universe, twisting and altering their paths as they journey from distant supernovae, black holes, and neutron stars. This interplay between cosmic rays and magnetic fields adds an extra layer of complexity to the study of these particles. Scientists can track the cosmic rays' paths back to their origins, identifying the sources of the immense energy that propels them across the universe. By tracing these particles, researchers are able to uncover hidden aspects of the cosmos, peering into phenomena that have remained elusive to human understanding. Through this process, we gain not only a better understanding of cosmic origins, but also a deeper knowledge of the fundamental forces that shape the universe itself. In the grand theater of our solar system, the sun plays a central role, periodically erupting with powerful bursts of radiation known as solar flares. These eruptions occur when the sun's magnetic field lines become tangled, causing them to snap back into place with explosive force. The energy released during these events is equivalent to millions of hydrogen bombs detonating simultaneously. The radiation from these solar flares spans the entire electromagnetic spectrum, from visible light to ultraviolet and X-rays, unleashing a torrent of particles that race across space at incredible speeds. Within just 8 minutes, the energy from these flares can travel from the sun to Earth, where it interacts with our planet's magnetic field and atmosphere, creating a cascade of effects that can disrupt the functioning of modern technology. The impact of solar flares on Earth is profound. As these bursts of energy reach our planet, they can interfere with telecommunications systems, knock satellites off course, and even cause power outages by damaging electrical grids. In extreme cases, they can induce geomagnetic storms that affect the global positioning systems, GPS, we rely on for navigation and the sensitive electronics aboard spacecraft. For astronauts, the danger is even more pronounced, as solar flares can pose significant health risks by increasing exposure to harmful radiation. To minimize the impact on human safety, airlines may reroute flights during significant solar events, keeping aircraft away from areas with heightened radiation levels. To better anticipate and mitigate these risks, scientists track solar activity as part of space weather forecasting. Through careful monitoring, researchers are able to predict when solar flares are more likely to occur and how they might affect Earth's infrastructure. The sun operates on an 11-year cycle of activity, with solar flares becoming more frequent during the peak of this cycle, known as the solar maximum. Understanding the patterns of this cycle and the underlying mechanisms behind solar flares is crucial for safeguarding technological systems and minimizing disruptions to daily life. The science of predicting solar flares, however, is far from straightforward. The sun's magnetic fields are inherently unpredictable, sometimes twisting and becoming tangled in ways that are difficult to foresee. These tangled magnetic fields are what ultimately trigger solar flares, but precisely when and how this energy will be released remains elusive. While scientists have developed models to study the behavior of the sun's magnetic fields and the solar flares that result from them, there is still a great deal of uncertainty about the specific conditions required for a flare to occur. As a result, even with the most advanced monitoring technologies, flare predictions are often inaccurate with researchers unable to provide definitive warnings in many cases. This unpredictability is a significant challenge, especially given the potential consequences of solar flare activity. While patterns in solar behavior can sometimes offer clues as to when a flare is more likely, these patterns are not foolproof. In some instances, flares erupt without any forewarning, catching even the most experienced solar scientists off guard. The ability to accurately predict when and where a solar flare will strike is an area of intense focus in heliophysics. By improving predictive models, scientists hope to minimize the risks associated with solar flares and protect the technology on which our modern world depends. The energy unleashed during a powerful solar flare can have far-reaching consequences for technology on Earth. These bursts of electromagnetic radiation and streams of charged particles can overwhelm satellite systems, distort communication signals, and cause permanent damage to sensitive electronic components. In the worst-case scenarios, solar flares can knock out power grids, causing widespread blackouts and disrupting everything from air traffic control to medical services. As the Earth becomes more dependent on technology, understanding and forecasting solar flares has become a crucial priority for scientists working to ensure the resilience of our technological infrastructure. Thus, the study of solar flares and cosmic rays is more than just an exploration of distant celestial phenomena. It is a key endeavor in understanding the forces that govern not only the universe, but also the intricate systems that sustain life on Earth. As we continue to unravel the mysteries of these cosmic events, we gain valuable insights that inform not only our scientific knowledge, but also our ability to protect the modern world from the unpredictable forces of space. One of the most pressing concerns in our modern, technology-driven world is the potential impact of high-energy particles emitted by the sun. These particles can significantly interfere with the delicate electronics aboard satellites, potentially causing malfunctions or, in the worst-case scenario, total failure. This poses a grave threat to critical services such as GPS, telecommunications, and weather forecasting, all of which rely heavily on the functionality of satellites. When these systems are disrupted, the ripple effects can be felt across the globe, underscoring the vulnerability of our infrastructure. However, the consequences of solar flares extend far beyond space. Solar activity can also severely affect electrical grids on Earth. When intense bursts of radiation from the sun, known as solar flares, interact with Earth's magnetic field, they can induce geomagnetic storms. These storms generate powerful surges in electrical currents that have the potential to overwhelm power stations. In the most severe cases, this can result in widespread blackouts or even permanent damage to critical infrastructure. The components most at risk are transformers, which play a vital role in regulating the distribution of electricity. Their delicate nature makes them particularly susceptible to the surges created by these geomagnetic storms, making it crucial for us to protect these vital assets. Historically, the impact of solar activity on Earth's infrastructure is not just theoretical. Events like the Quebec blackout of 1989 serve as stark reminders of how vulnerable our technology is to the unpredictable nature of solar flares. This incident, caused by a massive solar storm, plunged the Canadian province of Quebec into darkness for hours, affecting millions and costing billions in damages. It was one of the most significant power outages caused by a solar event, drawing attention to the pressing need for better preparedness in the face of such natural phenomena. Another often overlooked but equally critical effect of solar flares is their interference with radio signals. The intense bursts of radiation emitted by the sun can disrupt communication systems, particularly those that rely on high-frequency radio waves. This disruption can cause everything from minor signal distortion to the complete loss of communication, which poses significant challenges, especially in fields like aviation and maritime navigation. Both of these industries rely heavily on dependable communication systems to ensure the safety of passengers and cargo, and any disruption to these systems could lead to disastrous consequences. Given the increasing reliance on technology for everyday activities, the need to understand these solar impacts has never been more urgent. This growing awareness has sparked extensive research and preparation efforts across the scientific and technological communities. And with organizations worldwide, including space agencies like NASA and the National Oceanic and Atmospheric Administration, NOAA, are dedicated to monitoring solar activity with the goal of predicting its effects on our planet. This knowledge is essential not just for scientific curiosity, but for crafting more robust protective measures and contingency plans for our interconnected technological systems. One of the most crucial aspects of solar activity is the natural rhythm of the sun itself. Solar cycles, which oscillate roughly every 11 years, determine the levels of solar activity we experience. During a solar cycle, the sun moves between a solar minimum, with relatively low activity, and a solar maximum, where activity surges to its peak. We are currently in the midst of solar cycle 25, which began in December 2019. As this cycle progresses, scientists predict that solar activity will ramp up, peaking around 2025. This upcoming solar maximum is expected to be more intense than the previous cycle, solar cycle 24, and it could have a greater impact on both satellite operations and electrical grids on Earth. During a solar maximum, the sun's surface becomes increasingly active. Sunspots multiply, solar flares occur more frequently, and coronal mass ejections, large bursts of solar wind and magnetic fields, send high-energy particles into space. These events can wreak havoc on our satellites, disrupt communication systems, and even pose a direct threat to our power infrastructure on Earth. But despite the potential for chaos, solar activity can also create awe-inspiring beauty. In polar regions, the charged particles from the sun collide with Earth's atmosphere, creating vivid auroras that light up the night sky in brilliant colors. As we approach the peak of solar cycle 25, researchers at organizations such as NASA and NOAA are preparing for an uptick in solar phenomena. These scientists are carefully studying these solar patterns using sophisticated models and real-time observations to track the sun's behavior and predict how these bursts of energy will affect our planet. While the expected increase in solar activity presents both opportunities for scientific research and a reminder of the sun's dynamic nature, it also serves as a warning, a reminder that our relationship with the sun, the ultimate source of energy, is far more interconnected and fragile than we often realize. The study of these solar cycles is not just an academic pursuit. It is vital for ensuring that our technology remains safe, reliable, and resilient in the face of nature's unpredictable forces. Understanding the sun's activity and the forces it generates is a subject of great interest and significance in the scientific community. By studying solar cycles, scientists are not only able to deepen their understanding of the sun's behavior, but also to better predict its future activity, which has profound implications for life on Earth. As we approach a period of heightened solar activity, the importance of this research becomes even more evident. On one hand, the dynamic sun presents us with awe-inspiring displays of beauty, such as vibrant auroras that light up the night sky. On the other hand, the intense energy released by the sun can have significant, sometimes hazardous impacts on our technology-dependent society. Solar flares, in particular, are powerful bursts of energy that can disrupt communication systems, damage satellites, and even interfere with electrical grids. The history of solar activity has provided us with a few key examples of the potential dangers posed by these solar phenomena. One of the most notable events in this regard occurred in 1859 and has come to be known as the Carrington event. This event was a massive solar storm, so powerful that it generated auroras visible far beyond their usual range, reaching as far south as the Caribbean. But the Carrington event wasn't just a spectacle of nature. It had a significant impact on technology. Telegraph systems across Europe and North America were severely disrupted, with some operators experiencing electrical shocks and even witnessing sparks from the equipment. The severity of this event highlighted the vulnerability of early electrical technologies to solar storms, and it served as a stark reminder of how our growing reliance on electricity could be jeopardized by the sun's energetic outbursts. More recently, in 1989, a similar solar storm caused significant disruption in Quebec, Canada, where a geomagnetic storm triggered by solar activity led to the failure of power grids. This event, which left millions without electricity for nearly 9 hours, underscored the vulnerability of modern electrical infrastructure to solar disturbances. As society continues to become more dependent on electricity and digital technologies, the potential risks associated with solar flares grow more concerning. In particular, solar flares have the capacity to disrupt not only communication networks, but also critical satellite systems and navigation technology, which play a crucial role in everything from weather forecasting to global positioning systems. As the world becomes more interconnected and reliant on digital infrastructure, the need for preparedness against solar flares has never been more urgent. The damage caused by a solar storm could affect everything from power grids to national security systems, potentially leading to widespread chaos. To mitigate these risks, scientists continue to closely monitor solar conditions using advanced instruments and telescopes to predict when solar flares and coronal mass ejections (CMEs) are likely to occur. This ongoing research is essential to protecting the technology and infrastructure that modern society depends on. Understanding the historical impact of solar flares not only helps scientists predict future events, but also serves as a reminder that despite our technological advances, we remain at the mercy of forces beyond our control. As we continue to explore space and deepen our reliance on technology, it is essential to remain vigilant and prepared for the next solar event, which could have far-reaching consequences for our interconnected world. On a cosmic scale, there are other phenomena that can have similarly dramatic effects, though on a much grander and more distant scale. One of these phenomena is the gamma-ray burst, an incredibly powerful and fleeting explosion that occurs in distant galaxies. These bursts release an enormous amount of energy in the form of gamma rays, which are the most energetic type of electromagnetic radiation. The sheer intensity of gamma-ray bursts can be staggering, with some emitting as much energy in just a few seconds as the sun will produce over its entire lifetime. These bursts typically last for mere milliseconds to several minutes, but the energy released during this brief period is enough to outshine entire galaxies, making them some of the most intense explosions in the universe. Astronomers believe that gamma-ray bursts are often linked to the death of massive stars in a supernova event, or to the collision of compact objects like neutron stars. In either case, these explosive events are thought to be related to some of the most extreme physical conditions in the universe. Supernovae occur when a massive star exhausts its nuclear fuel and collapses under its own gravity, often forming a black hole in the process. As the star collapses, its core is surrounded by an accretion disk where material is drawn in by intense gravitational forces. This process generates immense heat and pressure, and the energy released can be channeled into highly focused jets that shoot out from the poles of the collapsing star at nearly the speed of light. These jets emit gamma rays that travel vast distances across the cosmos. Another source of gamma ray bursts is the collision of neutron stars, which are incredibly dense remnants of massive stars. When two neutron stars collide, they create extreme gravitational forces and can produce a black hole. This collision also generates an enormous amount of energy, including gamma rays, and often results in the ejection of matter at incredible speeds. These neutron star mergers are thought to be one of the primary sources of heavy elements in the universe, such as gold and platinum, further adding to their scientific significance. The energy released by gamma ray bursts is mind-boggling, equivalent to the total energy output of our sun over its entire 10 billion year lifespan. As scientists continue to study these events, they are not only gaining insights into the life cycles of stars, but also uncovering more about the extreme physics that govern the universe's most violent and dynamic phenomena. Gamma ray bursts provide a unique opportunity to observe and learn about the universe's early history, as the light from these bursts can travel billions of years before reaching Earth. In this sense, studying these bursts offers astronomers a glimpse into the distant past, allowing them to better understand the conditions that existed in the early universe, including how stars formed and how galaxies evolved. Gamma ray bursts are truly extraordinary phenomena that have captivated the imagination of scientists and the general public alike. Their immense energy and brief duration challenge our understanding of the universe and push the boundaries of astrophysics, driving scientists to explore the extreme conditions and processes that produce them. The study of gamma-ray bursts is a testament to humanity's ongoing quest to understand the universe, revealing the powerful, often violent forces that shape the cosmos. As research continues to advance, we may yet discover even more about these fascinating and mysterious explosions, uncovering new layers of knowledge about the nature of the universe itself. Gamma-ray bursts, GRBs, are among the most powerful and enigmatic phenomena in the universe. These explosions, capable of releasing an immense amount of energy, occur roughly several times a day in far-off galaxies. Despite their frequency on a cosmic scale, the occurrence of GRBs within our own galaxy, the Milky Way, is far rarer, estimated to happen only once every few million years. This rarity means that while these violent outbursts are common across the universe, the chance of one directly affecting Earth remains minimal. However, the potential consequences of such an event are profound, making the study of these bursts a key area of modern astrophysics. The core of the risk posed by gamma-ray bursts lies in their incredible energy output. A typical GRB releases more energy in just a few seconds than the Sun will emit over its entire 10 billion year lifetime. If one were to occur within the Milky Way and happen to be aimed directly at Earth, the effects could be catastrophic. The intense radiation produced by such an explosion could disrupt Earth's atmosphere, particularly the ozone layer, which acts as a shield protecting life from harmful ultraviolet UV radiation. The depletion of this protective layer could have severe ecological consequences, potentially causing a widespread collapse of ecosystems and endangering many species. Furthermore, the radiation from a GRB could lead to direct health risks for living organisms, both on the ground and in the air. Increased exposure to gamma rays could result in elevated rates of cancer, mutations, and other serious health problems for humans, animals, and plants alike. Such an event would not only have devastating consequences for individual species, but could also alter the delicate balance of life on Earth, creating a ripple effect that might take centuries to recover from. Luckily, the vast distances between stars in the galaxy act as a natural buffer, reducing the likelihood of a GRB occurring close enough to pose a direct threat to our planet. In fact, the chances of a GRB being aimed directly at Earth are exceedingly small, providing some degree of reassurance when considering the scale of these cosmic explosions. While this knowledge might offer comfort, it also serves as a reminder of just how fragile life on Earth is, particularly in the context of the wider, often hostile forces at play in the universe. In recent years, advances in technology have significantly improved our ability to detect gamma-ray bursts and understand their behavior. Satellite missions, in particular, have played a pivotal role in monitoring the skies for these high-energy events. One of the most important innovations in this field is the launch of the Fermi Gamma Ray Space Telescope in 2008. This mission, with its wide field of view, continuously scans the cosmos for gamma-ray emissions, enabling scientists to react quickly to GRBs as they occur. With the ability to detect bursts as they happen, researchers can begin their investigations almost immediately, collecting data on the bursts' origins and properties. Ground-based observatories are also contributing to this expanded understanding of GRBs. Instruments such as the Very High Energy Array and the High Altitude Water Cherenkov Observatory work in tandem with space-based telescopes, capturing secondary radiation produced when gamma rays interact with Earth's atmosphere. This dual approach enhances the precision with which we track and analyze these bursts, helping to refine our models of how and why they occur. The role of artificial intelligence, AI, in this field cannot be overstated. Machine learning algorithms are now being used to process vast amounts of data generated by both space and ground-based instruments. These algorithms can quickly identify patterns, anomalies, and potential bursts, significantly speeding up the detection process. In many cases, scientists can respond to a GRB within minutes, which opens the door to more comprehensive and rapid observational campaigns. These campaigns, using a range of wavelengths from radio waves to X-rays, allow researchers to capture a more detailed picture of these explosive events and their underlying physics. The future of GRB research looks even brighter, with the upcoming missions set to push the boundaries of our understanding further. The Gamma Ray Space Telescope, which is expected to be launched in the next few years, promises to capture even more detailed images and spectra of GRBs. This next-generation telescope will allow scientists to probe deeper into the mechanics of these events, helping to unravel the mysteries surrounding their origin and their role in the universe. Each new advancement not only strengthens our detection capabilities, but also expands our appreciation of the cosmos, shedding light on some of its most dramatic and awe-inspiring occurrences. Public understanding of gamma-ray bursts is critical for several reasons beyond just the excitement of space exploration. GRBs provide us with unique insights into fundamental astrophysical processes such as star formation and the life cycles of massive stars. When individuals become informed about these phenomena, they engage more deeply with the world of science, fueling a collective curiosity about the universe and the nature of reality itself. This engagement fosters a society that values scientific inquiry and innovation, which in turn supports continued progress in cosmology and astrophysics. Moreover, gamma-ray bursts offer a window into the distant past. Each burst carries valuable information about the conditions that existed in galaxies billions of years ago, giving us clues about the early universe. By studying these events, scientists are able to piece together a more complete picture of cosmic evolution, helping us understand how galaxies formed and how the universe has evolved over time. This research also contributes to our broader understanding of fundamental forces, including dark matter and dark energy, two of the most profound mysteries in modern physics. As public awareness of gamma-ray bursts grows, so too does the potential for increased investment in research and educational initiatives. When the general public recognizes the significance of such phenomena, it creates a fertile environment for funding bodies to support research in high-energy astrophysics. This financial backing is essential for furthering our understanding of the universe and for advancing the technologies that can one day have far-reaching applications in fields such as medicine, engineering, and environmental science. In conclusion, while the odds of a gamma-ray burst threatening life on Earth are incredibly slim, the study of these cosmic events offers us profound insights into the workings of the universe. From improving our understanding of star formation and cosmic evolution to driving technological innovations, GRBs continue to captivate scientists and the general public alike. As our detection capabilities improve, we are not only uncovering the mysteries of these powerful explosions, but also deepening our understanding of the universe in ways that will benefit humanity for generations to come. Engaging the public with the awe-inspiring phenomena of the cosmos, such as the mysterious and powerful nature of asteroids, does more than just capture the imagination. It ignites curiosity in young minds, propelling them toward careers in science, technology, engineering, and mathematics, STEM. When we expose the next generation to these cosmic wonders, we don't just stir their fascination, we plant the seeds for innovation and discovery, ultimately shaping the future of scientific exploration. This fascination with the universe fosters a culture of inquiry and progress, one that can echo across generations, driving humanity's quest to understand the universe in ever more profound ways. The history of Earth itself has been dramatically influenced by asteroid events. One of the most monumental of these occurrences was the asteroid impact that led to the extinction of the dinosaurs, an event that took place around 66 million years ago. This catastrophic impact, which struck the Yucatan Peninsula in what is now Mexico, left behind the massive Chicxulub crater. The asteroid that caused this devastation is thought to have been approximately 10 kilometers wide. Upon impact, the energy released was mind-boggling, equivalent to millions of atomic bombs. The resulting devastation triggered a series of environmental catastrophes, from massive wildfires to a global winter, which permanently altered the planet's climate. These changes led to the extinction of about 75% of Earth's species, marking a pivotal turning point in the planet's evolutionary history. Most notably, the dinosaurs, which had dominated the planet for over 160 million years, vanished, making way for the rise of mammals and eventually human life. Yet asteroid impacts have not only shaped the distant past, but have continued to leave their mark on Earth's history. Approximately 450 million years ago, during the Ordovician-Silurian extinction event, an impact or a series of impacts may have been responsible for one of Earth's most significant mass extinctions. Though the precise causes remain debated, some scientists propose that a massive asteroid or comet could have triggered rapid climate changes that led to an ice age, decimating marine life. This event resulted in the loss of about 85% of marine species, fundamentally transforming Earth's ocean ecosystems and setting the stage for the future evolution of life on Earth. In more recent history, a smaller asteroid, one that didn't lead to global extinction but still demonstrated the potential for significant destruction, remains one of the most fascinating examples of the unpredictable power of celestial bodies. On June 30th, 1908, the Tunguska event occurred in Siberia. An asteroid, or possibly a comet, exploded in the atmosphere, releasing an energy equivalent to 15 megatons of TNT. The blast flattened over 2,000 square kilometers of forest, but curiously, no crater was left behind. The absence of a crater suggests the asteroid had exploded in the air before reaching the ground, underscoring the unpredictability of these celestial objects and the potential for destruction they pose, even if they are relatively small in size. Each of these events, whether the mass extinction that wiped out the dinosaurs, the dramatic shifts in marine life, or the explosion over Tunguska, demonstrates the profound and often unexpected impacts that asteroids have had on Earth. They serve as a potent reminder of our planet's vulnerability and the dynamic relationship between Earth and the cosmos. As we continue to explore the vast universe, it becomes ever more critical to study asteroids not only to understand the history they have shaped, but also to prepare for the future and the challenges they may present. Today, scientists classify asteroids into three primary categories based on their composition and location within the solar system: C-type, carbonaceous; S-type, silicaceous; and M-type, metallic. C-type asteroids, often dark and rich in carbon, are typically found in the outer reaches of the asteroid belt. S-type asteroids, composed mainly of silicate minerals and metals, are more common in the inner regions of the asteroid belt. M-type asteroids, which are rare, consist mainly of metallic iron and nickel. To assess the potential threat posed by asteroids, scientists constantly monitor their orbits using advanced tools such as telescopes and radar. By tracking these objects, scientists can calculate their trajectories with remarkable precision, allowing them to predict their future paths. An asteroid is considered potentially hazardous if its orbit brings it within 0.02 astronomical units of Earth and it is larger than 140 meters in diameter. These two factors, proximity to Earth and size, are critical for determining the risk an asteroid poses. However, size and proximity are not the only factors scientists consider when evaluating an asteroid's potential danger. The composition and physical properties of an asteroid also play a crucial role in predicting its impact on Earth. Spectroscopic techniques, which involve analyzing the way an asteroid reflects light, help scientists determine its surface composition. This, in turn, provides valuable insights into the asteroid's structure and how it might behave if it were to collide with Earth, whether it would break apart upon entry into the atmosphere or deliver a devastating explosion upon impact. As our understanding of asteroids deepens, so too does our ability to predict their behavior and assess the threats they may pose. This knowledge, gained through years of research and observation, not only helps us safeguard the future of our planet, but also contributes to a broader understanding of the universe's processes and the forces that have shaped our world. By studying these ancient relics of the solar system, we gain invaluable insights into both our past and the potential challenges that lie ahead. The exploration of asteroids is not just about defending Earth from potential threats. It's about understanding the building blocks of our own existence and the cosmos itself. Asteroid deflection strategies are no longer just a speculative idea. They are becoming an essential part of humanity's long-term survival strategy. As our understanding of near-Earth objects, NEOs, grows, so does our ability to prevent a potentially catastrophic asteroid impact. The race is on, as future missions aim to study these space rocks up close, providing valuable data that could one day allow us to alter their course and protect our planet. This emerging field is a testament to the incredible progress we're making in planetary defense, but it also highlights the increasing urgency of ensuring that we're prepared for any cosmic threats that may come our way. Ongoing research is advancing rapidly, and as large-scale surveys and observational technologies continue to improve, scientists are tracking an increasing number of these potentially hazardous objects. These efforts are not just about understanding the threats, but also about identifying solutions to alter the trajectory of these space bodies should they pose a risk to Earth. One such risk looms large in the year 2031, when an asteroid named 14,060 will make an extremely close approach to our planet. Measuring nearly the size of a city block, it will pass by Earth at an extraordinarily close distance, offering astronomers an unprecedented opportunity to study its surface and characteristics. This flyby promises to unlock valuable insights into the early solar system, offering clues about the conditions that existed when our own planet was forming. At the same time, scientists are continually monitoring other asteroids that could pose a danger, especially those that cross Earth's orbit. NASA's Near-Earth Object Program, along with other space agencies, actively tracks these objects to assess their potential risks. As of now, millions of asteroids are scattered throughout the solar system, and the need to map their orbits is more pressing than ever. Having an accurate understanding of these paths is vital for developing strategies to protect our planet. One event that continues to capture the public's attention is the 2029 approach of asteroid Apophis. Once feared to be a significant threat due to its close pass with Earth, extensive calculations have since reassured the public that it will harmlessly glide by. This event will serve as a prime opportunity for outreach, showing how scientific advancements have transformed what was once a source of anxiety into a valuable teaching moment about the role of space science in mitigating existential threats. It will also serve to highlight how, through a greater understanding of these objects, we can diffuse fear and foster a sense of wonder about the universe. Looking ahead, asteroid exploration missions will continue to shape our understanding of these ancient space rocks. Spacecraft like those that visited asteroids Bennu and Ryugu have already demonstrated the potential for collecting samples and studying them in greater detail. These missions provide insights not only into the materials that make up asteroids, but also into the early conditions of the solar system, offering clues about the origins of life on Earth. One exciting aspect of these missions is their potential to assess the feasibility of mining these rocks for resources that could one day support long-term space travel. In parallel to exploration, scientists are focusing on asteroid deflection technologies that could one day prevent an asteroid impact. These technologies rely on the fact that many asteroids follow predictable paths. With enough warning, scientists could develop strategies to change an asteroid's course, preventing a collision with Earth. One of the most studied techniques is the kinetic impactor method. This approach involves sending a spacecraft at high speed to collide with the asteroid. The impact would impart enough energy to nudge the asteroid onto a new course, gradually altering its trajectory over time. Even a small shift in position, when compounded over the course of its journey, could result in a dramatic change in its approach to Earth. In September 2022, NASA showcased this method in a highly publicized mission called the Double Asteroid Redirection Test, DART. The spacecraft successfully redirected an asteroid named Dimorphos, proving that this technique could be a viable solution in the event of a future asteroid threat. However, this is just one of several methods under consideration. Another approach being researched is the gravitational tractor technique, which would involve positioning a spacecraft near the asteroid for an extended period. The spacecraft's gravity would subtly alter the asteroid's trajectory over time without the need for a physical collision. While this technique requires a significant amount of time and would likely be best suited for larger asteroids, it provides a non-invasive option for deflection. More extreme proposals, such as using nuclear devices to disrupt or divert an asteroid, have also been considered, though they come with serious ethical and safety concerns. As we advance in our understanding of these technologies, it's becoming increasingly clear that early detection is key. The window of opportunity to implement deflection strategies is limited, and the real challenge lies in identifying a threat early enough to take effective action. The faster we detect potential hazards, the better our chances of preventing disaster. One of the most exciting missions currently underway is NASA's Psyche mission, which is focused on exploring a unique metallic asteroid of the same name. Located in the asteroid belt between Mars and Jupiter, Psyche is believed to be the exposed nickel-iron core of a protoplanet. This mission will help scientists better understand the processes involved in the formation of rocky planets like Earth. Psyche offers an opportunity to study materials from the very heart of a planetary body, potentially providing clues about the formation of our solar system. Meanwhile, Japan's Hayabusa 2 mission has already returned samples from the asteroid Ryugu. This groundbreaking mission, which successfully collected material from the surface of Ryugu and brought it back to Earth in late 2020, has provided scientists with essential data about the building blocks of the solar system. The samples are still being analyzed, and early results may reveal important information about the origins of water and organic materials on our planet, possibly shedding light on how life itself began. Looking to the future, NASA's DART mission will again test asteroid deflection technology, this time targeting the asteroid Didymos and its moonlet, Didymoon. The mission will deliberately crash a spacecraft into Didymoon in order to evaluate how effective the kinetic impact method is at altering an asteroid's path. As space agencies continue to test and refine these strategies, the idea of planetary defense is becoming more than just a theoretical discussion. It's an active, ongoing project. In the coming decades, it's likely that public interest in asteroid events will only grow. With the increasing number of asteroids being monitored, the potential for dangerous encounters will remain a topic of global conversation. But as these missions unfold, they offer hope and proof that humanity is not only capable of defending itself from cosmic threats, but also poised to unlock the secrets of our solar system's distant past. Through these efforts, scientists are helping to ensure that humanity remains safe while simultaneously fostering curiosity about the mysteries of space. In recent years, a growing number of international teams have set their sights on ambitious missions to some of the most intriguing and mysterious objects in our solar system, asteroids. Among the most prominent proposals are missions to the asteroid Bennu, as well as various other potential targets within the near-Earth object category. These future endeavors represent a remarkable leap forward in our quest to understand not only the nature of these celestial bodies, but also their role in the broader cosmic tapestry. As interest in asteroids continues to rise, scientists are eager to explore their rich potential, whether in terms of resources such as metals and water, or for what they can reveal about the history of the solar system and the preservation of life on Earth. The pursuit of asteroid exploration reflects a rapidly growing fascination with the building blocks of our solar system. These rocky remnants offer invaluable clues about the early conditions that led to the formation of planets, as well as the crucial role asteroids may have played in the delivery of organic materials to Earth. In a sense, these missions are not only about reaching out to the cosmos, they're a journey back in time, offering insights into a primordial past that could help us safeguard our future. At the same time, discoveries in astronomy have fundamentally altered our understanding of the universe and the forces that shape it. One of the most groundbreaking advancements came in 2015 with the detection of gravitational waves, ripples in space-time produced by cataclysmic cosmic events, such as the merging of black holes or neutron stars. The confirmation of these waves not only validated predictions made by Einstein a century earlier, but also unlocked a new observational window to the universe. By studying these phenomena, scientists have gained unparalleled insights into the life cycles of stars and the violent dynamics of some of the most extreme environments imaginable. These ripples in space-time are not just signals from far-off cataclysms, they are windows into the very heart of creation itself. In a similar vein, another captivating discovery came from the observation of fast radio bursts, brief but intense flashes of radio frequency emissions originating from distant galaxies. For years, the origin of these enigmatic bursts was shrouded in mystery. However, the advent of more advanced telescopic technologies allowed astronomers to trace these signals back to their source. These bursts are now thought to come from magnetars, highly magnetized remnants of supernova explosions, and their discovery has ignited a new wave of interest in understanding the conditions required for these extreme cosmic events. The search for exoplanets, or planets orbiting stars beyond our solar system, has also taken a remarkable leap forward. Missions like NASA's Transiting Exoplanet Survey satellite, TESS, have reported thousands of potential planetary systems, each one offering a unique glimpse into worlds far beyond our imagination. These discoveries are revolutionizing our understanding of atmospheric compositions, planetary environments, and the possible existence of biosignatures, chemical indicators that life may exist beyond Earth. With each new exoplanet found, the age-old question of whether we are alone in the universe becomes ever more pressing, sparking debate and wonder about humanity's place in the cosmos. Moreover, the ongoing study of dark energy and dark matter has further reshaped cosmological theories, leading to a more nuanced understanding of the universe's makeup. Dark energy, which seems to be driving the accelerated expansion of the universe, has proven to be far more complex than once thought. As researchers continue to probe the nature of dark matter, elusive substance that makes up a large portion of the universe's mass, but has yet to be directly observed, the potential for groundbreaking discovery grows. These revelations could eventually unlock new insights into the fundamental structure of the universe and its ultimate fate, offering answers to some of the most profound questions in science. Taken together, these discoveries illustrate a key point. The cosmos is an ever-evolving frontier that constantly challenges our preconceived notions. What we once thought we understood about the universe is continually evolving, and each new piece of the cosmic puzzle compels us to push deeper, to explore further, and to redefine our understanding of existence itself. Since the launch of the first artificial satellite, space exploration has significantly advanced humanity's understanding of cosmic phenomena. This ongoing journey into the unknown has expanded our horizons, allowing us to observe the universe with unprecedented clarity. Instruments aboard spacecraft and telescopes have captured images and data from distant stars, galaxies, and nebulae, enriching our knowledge of their formation, evolution, and behavior. One of the most significant contributions of space exploration is the discovery of cosmic microwave background radiation, a faint afterglow from the Big Bang. This remnant energy provides essential evidence supporting the Big Bang theory, offering a glimpse into the earliest moments of the universe and its subsequent expansion. Missions such as the Hubble Space Telescope have further expanded our view of the cosmos, revealing the existence of billions of galaxies and providing evidence of phenomena like dark matter and dark energy. These mysterious forces constitute much of the universe, yet their true nature remains elusive, posing one of the greatest scientific challenges of our time. Space exploration has also opened up new avenues of inquiry into other celestial bodies, most notably Mars, where ongoing missions have significantly enhanced our understanding of planetary atmospheres, geology, and the potential for life beyond Earth. The discovery of water, whether in the form of ice or vapor on Mars, as well as on the icy moons of Jupiter and Saturn, suggests that these distant worlds may harbor conditions suitable for life. This revelation has ignited debates about the possibility of microbial life beyond Earth, raising fundamental questions about our place in the universe and the uniqueness of life as we know it. Additionally, the study of asteroids and comets has provided crucial clues about the origins of our solar system. These ancient celestial bodies, which predate the formation of the planets, offer a unique window into the conditions that existed in the early solar system and may hold the key to understanding the building blocks of life on Earth. Understanding these objects can help us uncover the chemical and physical processes that gave rise to our planet, shedding light on the origins of water and organic compounds that could have sparked the rise of life itself. In the realm of cosmic phenomena, space exploration has transformed our understanding of black holes and neutron stars. Through the detection of gravitational waves, particularly by observatories like LIGO, scientists have gained a new way to observe some of the most violent and dramatic events in the universe. The collision of black holes, once thought to be undetectable, has now become a fascinating area of study. These collisions, as well as the behavior of neutron stars, provide unprecedented insights into the nature of space, time, and gravity. The ongoing investment in space exploration, driven by both government and private sector initiatives, continues to fuel our curiosity and our drive to understand the cosmos. This ever-expanding field not only enriches our scientific knowledge, but also inspires humanity to contemplate the big questions of existence. As we gaze ever further into the stars, we are reminded of the mysteries that still await us. Mysteries that, in their exploration, could change the way we see ourselves and our place in the universe. Telescopes and satellites are, of course, the fundamental tools that enable astronomers to make sense of the vastness of space. These instruments allow us to observe distant celestial objects and events, offering invaluable data about phenomena that occurred billions of light years away. Ground-based telescopes, which capture visible light, rely on powerful lenses and mirrors to magnify and clarify our view of stars, planets, galaxies, and other cosmic wonders. Meanwhile, space-based observatories can peer into the farthest reaches of the universe without the interference of Earth's atmosphere, providing a clearer, more detailed picture of the cosmos. Together, these technologies form the backbone of modern astronomy, enabling us to continue our journey of discovery and pushing the boundaries of human knowledge ever outward. However, the ability of telescopes and satellites to unveil the mysteries of the cosmos is not without its challenges. Earth's atmosphere, while essential for supporting life, distorts the light that reaches us from distant celestial bodies. This distortion, which is caused by the atmospheric layers through which light must pass before it reaches the ground, can obscure crucial details, making the work of ground-based observatories difficult and limited. To overcome these limitations, scientists and astronomers have turned to space-based telescopes, such as the Hubble Space Telescope, which operates above the thick, blurring layers of Earth's atmosphere. Positioned far above any atmospheric interference, these space telescopes can capture crisp, uninterrupted images of distant stars, galaxies, and other cosmic objects. Their ability to observe across a wide range of wavelengths, ranging from ultraviolet to infrared light, allows for a more nuanced understanding of the universe. With this expansive view, astronomers can examine celestial phenomena that would otherwise remain hidden or barely detectable, such as the obscure dust surrounding stars or the distant, far-off galaxies shrouded in cosmic fog. By utilizing the full spectrum of light, from wavelengths visible to those beyond the human eye, space telescopes open a window into the otherwise invisible parts of the universe. Satellites, too, play a crucial role in expanding our cosmic knowledge. While telescopes are essential for observing visible and infrared light, there are other wavelengths, such as gamma rays and X-rays, that cannot penetrate Earth's atmosphere. This is where space-based satellites prove invaluable. Some of these satellites are specifically designed to detect these high-energy phenomena, which are essential for studying energetic events like supernovae, black hole collisions, and the violent processes unfolding within active galactic nuclei. Without these space-based instruments, we would be largely blind to the most extreme and energetic occurrences in the universe. By capturing data from different perspectives, telescopes and satellites work hand in hand to provide a comprehensive and detailed view of cosmic events. Their combined efforts allow scientists to piece together the puzzle of the universe, offering a more complete and multifaceted understanding of the forces and activities that shape it. The collaboration between ground-based telescopes and space satellites ultimately enhances our knowledge of the cosmos, helping to drive discoveries that continuously challenge our understanding of physics and the fundamental nature of space-time itself. The technological advancements in both space and ground-based observational tools are rapidly progressing. With each new breakthrough, our ability to explore and understand the universe expands further. These advancements not only refine existing methods, but also promise to unlock new avenues of exploration, revealing the many mysteries that still lie beyond our reach. The ever-evolving technology ensures that astronomers can continue to push the boundaries of what we know about the cosmos. In recent years, the field of astronomy has been transformed by the rise of citizen science. These projects empower ordinary people, regardless of their scientific background, to actively participate in research and discovery. By opening up opportunities for public involvement, these initiatives harness the collective power of tiers to contribute to groundbreaking work that would otherwise be impossible for a small group of professional scientists to accomplish on their own. One of the most notable examples of citizen science in the field of astronomy is the Galaxy Zoo project. This initiative invited volunteers to help classify millions of galaxy images collected by telescopes. By tapping into the collective intelligence and varied perspectives of participants, the project uncovered new patterns and structures within galaxies, leading to significant discoveries about their formation and evolution. The success of Galaxy Zoo is just one example of how citizen science has become a powerful tool in expanding our knowledge of the universe. Other citizen-driven projects like Zooniverse provide platforms for a wide range of astronomical studies, where volunteers contribute by classifying images, identifying unusual patterns, and even searching for new cosmic objects. These platforms have expanded the reach of astronomical research, enabling discoveries that might otherwise go unnoticed by automated systems or professional astronomers. Beyond classification, citizen scientists also play an essential role in monitoring the night sky for variable stars and transient events such as supernovae. The vigilance of amateur astronomers has led to the discovery of numerous new asteroids and comets. Their keen observations often catch events that larger, automated systems miss, proving that dedicated individuals can make substantial contributions to our understanding of the universe. Furthermore, these citizen-led initiatives create a sense of community among astronomy enthusiasts. Participants from all walks of life share their findings and insights with one another, fostering a global network of knowledge exchange. The shared excitement over new discoveries brings together people who are united by their love of the stars, creating an ever-expanding, collaborative effort to unlock the secrets of the cosmos. As more individuals engage in scientific exploration, the collective understanding of cosmic events deepens, reinforcing the idea that the pursuit of knowledge is not limited to traditional scientific institutions, but is a universal endeavor accessible to anyone with curiosity. Looking ahead, the future of cosmic discovery is rich with potential, thanks to new tools and missions that promise to unveil previously hidden aspects of the universe. One such mission is the James Webb Space Telescope, which launched in late 2021. The Webb telescope is designed to explore the universe in infrared light, allowing it to peer deeper into space than any previous observatory. This will enable scientists to observe distant galaxies and star-forming regions that are currently obscured by cosmic dust. By studying the early universe, Webb will offer insights into the formation of stars and galaxies, shedding light on epochs that have remained largely a mystery until now. Equally exciting is the Vera-C Rubin Observatory, which is set to conduct a comprehensive survey of the entire sky. The observatory will use a wide-field telescope to gather vast amounts of data in a relatively short time. The Legacy Survey of Space and Time, conducted by the Rubin Observatory, will allow astronomers to monitor the sky for transient events such as supernova explosions, asteroids, and even gravitational waves. The data collected will be invaluable for understanding the dynamic and ever-changing nature of the universe, helping scientists to identify rare cosmic phenomena that could lead to major breakthroughs in our knowledge of space. As new technologies and missions continue to emerge, the pursuit of understanding the universe grows ever more ambitious. These efforts, along with the invaluable contributions of citizen scientists, ensure that the exploration of the cosmos will continue to expand, revealing more secrets of the vast, mysterious universe in which we reside. Advancements in gravitational wave astronomy are opening the door to an exciting new era of discovery, one that is poised to reshape our understanding of the universe. With the groundbreaking work of the Laser Interferometer Gravitational Wave Observatory, LIGO, and its planned future upgrades, we are inching ever closer to detecting the faint ripples in space-time caused by some of the most dramatic and catastrophic events in the cosmos. such as the merging of black holes and neutron stars. These ripples, known as gravitational waves, carry with them information about the most violent forces in the universe, allowing us to observe phenomena that would otherwise be hidden from view. The upcoming expansions in the range of detectable frequencies will make it possible for future missions to uncover an entirely new spectrum of cosmic events. This will lead to a deeper and more nuanced understanding of the universe's most energetic processes, potentially unlocking mysteries that have eluded scientists for centuries. With each new technological leap, gravitational wave astronomy is proving to be a crucial tool in uncovering the hidden workings of the cosmos, revealing the previously invisible events that drive the evolution of galaxies, stars, and black holes. But that is not all. Space-based observatories, like the proposed Large Ultraviolet Optical Infrared Surveyor, LUVOIR, will soon have the capability to peer even further into the universe, focusing on the study of exoplanets and their atmospheres. These observatories will search for biosignatures, indicators of life, offering a fresh and powerful approach to the search for life beyond Earth. With the LUVOIR and similar missions, astronomers will be able to observe distant planetary systems in unprecedented detail, providing the tools necessary to study the potential for life on worlds orbiting distant stars. These ambitious projects, along with other planned space missions, are expanding the horizon of astronomical research. The discovery of new cosmic phenomena, from the birth of stars to the formation of planetary systems, will broaden our understanding of the universe's origins and its vast potential for harboring life. The technology being developed for these missions is advancing rapidly, allowing humanity to explore corners of the universe that were previously inaccessible. Each mission brings us closer to unveiling the mysteries of our universe, creating an ever-expanding toolkit for astronomers that will continue to evolve with future breakthroughs. Throughout history, humanity has been captivated and often mystified by the celestial events that unfold in the skies above. Ancient civilizations, long before modern telescopes and scientific methods, attributed great significance to phenomena such as solar eclipses, meteor showers, and planetary alignments. These events were often seen as omens, messages from the gods, or signs of fate. For example, the ancient Mayans tracked the movements of celestial bodies with extraordinary precision, developing complex calendars that aligned with these cosmic occurrences. These calendars were not just tools for tracking time. They were also integral to religious and agricultural practices, deeply influencing the rituals and ceremonies of the Maya people. Similarly, the ancient Egyptians believed that the stars and planets held great power over the fate of their kingdom. Their religious practices often revolved around celestial phenomena, with temples and monuments aligned to astronomical events. The movements of the heavens were seen as the will of the gods, guiding everything from the annual flooding of the Nile to the rise and fall of rulers. In many cultures, the appearance of comets was interpreted as a portent of significant change, often linked to the death of a ruler or the rise of a new dynasty. Halley's Comet, which has a predictable orbit of approximately 76 years, is one such celestial visitor that has long captured the human imagination. The Chinese have recorded sightings of Halley's Comet for centuries, interpreting its appearance as a harbinger of dramatic change, often linked to the fate of emperors and the stability of dynasties. In Europe, comets like Halley's were met with a mixture of awe and superstition, leading to a wide range of interpretations, from divine warnings to the omen of impending doom. These beliefs were not limited to comets. Other cosmic events, such as supernovae, also captured the attention of ancient peoples. In ancient Rome, the sudden appearance of bright stars or other unusual celestial phenomena was seen as a sign from the gods, a divine message that needed to be interpreted by historians and scholars. These occurrences, often cataloged in ancient texts, inspired both scientific inquiry and mythological narratives, where deities were frequently imagined as controlling the movements of the stars and planets. As human understanding of the universe progressed, these mythological frameworks began to give way to more empirical scientific explanations. The development of the telescope in the early 17th century marked a turning point, allowing humanity to peer deeper into space and discover that the heavens were far more complex and dynamic than had been previously imagined. The advent of modern physics, with its profound insights into gravity, light, and the nature of space-time, provided the tools needed to explain the phenomena that had once been shrouded in mystery. What was once viewed as divine or supernatural became, through scientific investigation, a series of natural processes governed by the laws of physics. Today, as astronomers use advanced instruments to study the vast expanse of the universe, the connection between ancient mythologies and modern science is still apparent. Many of the events that once inspired stories of gods and omens are now understood through the lens of astrophysics, offering a more comprehensive and awe-inspiring view of the cosmos. But even as we decode the scientific explanations behind these celestial events, the sense of wonder they inspire remains as powerful as ever, reminding us of the vastness of the universe and humanity's never-ending quest to understand its mysteries. However, the awe and wonder evoked by cosmic events continue to unify diverse cultures, emphasizing the profound and shared human connection to the cosmos, one that transcends time, space, and geographic boundaries. These celestial phenomena, from eclipses to comets, serve as both scientific curiosities and powerful cultural symbols, constantly reminding us of our collective curiosity and our enduring quest to understand our place in the vast universe. For millennia, cosmic events have captured the human imagination, shaping the myths and legends of countless civilizations. The fiery streaks of comets slicing through the night sky, or the rhythmic dance between the moon and the sun, have been more than just astronomical phenomena. They have served as powerful symbols within the folklore of different cultures. Ancient civilizations often turned to the heavens for answers, interpreting these celestial occurrences as omens or messages from the divine. The sudden appearance of a comet, for instance, was often seen as an omen of doom or a herald of significant change, such as the overthrow of a king or the rise of a new dynasty. Similarly, solar eclipses, rare and awe-inspiring, were often viewed with reverence, seen as mysterious acts of the gods, signaling monumental shifts in the natural order. In many traditions, these celestial events were not merely occurrences in the sky, but were deeply woven into the fabric of religious and cultural beliefs. In Norse mythology, for example, the sun was chased across the sky by a wolf named Skull, while his brother Hati pursued the moon. This celestial chase emphasized the eternal conflict between light and darkness, a struggle mirrored in the lives of mortals on Earth. These stories helped explain the cycles of the day and night, as well as the larger mysteries of the cosmos, offering a sense of control over the unpredictable nature of the world. Beyond individual celestial events, the night sky itself, with its constellations and star clusters, has played an equally important role in shaping cultural narratives. For example, the Pleiades star cluster, often called the Seven Sisters, has inspired mythologies in numerous cultures. From marking the arrival of spring to signaling the start of the planting season, the Pleiades held symbolic meaning for different peoples across time and geography. These constellations and the stories associated with them not only helped early societies make sense of their natural world, but also reinforced cultural values, social norms, and agricultural practices. Today, as we continue to explore the vastness of our universe, we gain new insights into the nature of cosmic events. With the advent of modern science and technology, we are able to understand these phenomena in ways our ancestors could only dream of. Yet, the stories and myths they left behind still serve as a poignant reminder of our intrinsic connection to the cosmos. These narratives highlight humanity's timeless search for meaning, and the way in which celestial events have shaped both our cultural heritage and our understanding of the universe. The influence of cosmic events extends far beyond ancient folklore and myth. Over the centuries, these phenomena have had a profound impact on art and literature, inspiring some of the most iconic works in human history. The arrival of comets, such as Halley's Comet, has long been a source of both awe and fear, sparking a flurry of artistic and literary interpretations. In the Renaissance, for example, the appearance of such celestial bodies prompted deep philosophical and theological discussions about the relationship between the heavens and human life. Artists and writers used these celestial events to explore themes of fate, divine will, and the mysteries of existence. The heliocentric model of the universe, first proposed by Nicolaus Copernicus, marked a revolutionary moment in human thought. This new understanding of our place in the cosmos led to dramatic shifts in art and literature. Writers like Galileo Galilei used celestial observations to challenge the long-held geocentric views of the universe, advocating for a more scientific approach to understanding the natural world. Later, during the Romantic period, poets such as John Keats and Lord Byron reflected on the vast beauty and mystery of the night sky, capturing the sublime grandeur of the universe through verse. The 20th century brought further advances in astronomy, deepening our understanding of the universe in ways previously unimaginable. The discovery of black holes and the development of the Big Bang theory opened up new avenues for exploration and artistic expression. Science fiction authors like Arthur C. Clarke began to envision a future where space exploration could become a reality, inspiring generations of readers to dream of what lies beyond our planet. In the visual arts, painters like Vincent van Gogh sought to capture the swirling energy of the night sky, creating masterpieces such as Starry Night that evoke the emotional resonance of cosmic phenomena. Even today, celestial events such as lunar landings and meteor showers continue to inspire contemporary artists and writers. The thrill of discovery, whether it's the landing of a probe on a distant comet or the first human steps on the moon, invites artists to reflect on humanity's relationship with the universe. These events, both awe-inspiring and challenging, serve as a reminder of the boundless imagination that drives our quest to explore and understand the cosmos. Throughout history, cosmic events have not only shaped cultural narratives, but have also catalyzed scientific inquiry and exploration. The arrival of supernovae, for example, has provided astronomers with remarkable insights into the processes of stellar evolution. When a star reaches the end of its life and explodes in a supernova, it releases elements such as gold and uranium into the cosmos, enriching the universe with the very building blocks of life. This realization has spurred physicists to delve deeper into the processes of nucleosynthesis, shedding light on the creation of elements crucial for life as we know it. Similarly, comets, once seen as harbingers of change, continue to fascinate scientists today. The study of these icy bodies has opened new doors in our understanding of the early solar system and the origins of life itself. Missions like ESA's Rosetta, which landed a probe on the comet 67P Churyumov-Gerasimenko, have provided unprecedented data on the composition of comets, offering insights into the formation of our solar system. By analyzing a comet's chemical makeup, scientists can learn about the conditions that existed in the early solar system and, more importantly, how these conditions may have paved the way for life on Earth. As we study these ancient relics from the cosmos, we also consider the possibility that comets may hold clues to life beyond our planet. In every era, cosmic events have inspired not just awe, but a deep curiosity about our place in the universe. From ancient mythologies to modern scientific discoveries, the stars, planets, and phenomena above have driven humanity's quest for knowledge, offering both answers and new mysteries to explore. These events, in all their wonder, serve as a reminder of our constant search for meaning and connection to the vast cosmos that surrounds us. Cosmic background radiation, discovered as a remnant from the Big Bang, marks one of the most profound breakthroughs in cosmology. This discovery has significantly advanced our understanding of the universe's expansion, cementing the Big Bang theory as the prevailing explanation for the origins of the cosmos. The detection of this faint radiation, relics of the intense heat that once filled the universe, has provided pivotal evidence supporting the theory, offering a glimpse into the very first moments after the birth of our universe. This discovery, however, has had implications far beyond the confines of theoretical physics. It has driven an array of technological innovations, reshaping the tools and techniques we use in the pursuit of knowledge. Satellite technology, for example, owes much to these advancements, with imaging methods developed for studying cosmic radiation now playing a vital role in other scientific disciplines. These technologies have applications in medicine, environmental monitoring, and even telecommunications, extending the reach of cosmological research to impact daily life in ways we rarely consider. In essence, studying cosmic background radiation has sparked technological revolutions that ripple through multiple fields, offering benefits far beyond the stars themselves. The search for answers to the mysteries of the universe embodied by cosmic phenomena continues to drive humanity's quest for knowledge. These events challenge our understanding and inspire a collective yearning to look beyond our earthbound existence. They fuel ambitious missions to explore distant planets and moons, igniting discussions about humanity's role in the vast cosmic narrative. In this way, scientific inquiry not only enriches our understanding of the cosmos, but also promotes a global collaboration among nations. As we pool intellectual resources and technological expertise, we push the boundaries of what we know and continue the exploration of the final frontier, space. Contemporary cultures have found numerous ways to commemorate and celebrate these awe-inspiring cosmic events, underscoring humanity's deep, enduring connection to the universe. One of the most striking expressions of this bond can be seen during astronomical phenomena like solar eclipses and meteor showers. Communities around the world gather to witness these extraordinary occurrences, turning these celestial spectacles into moments of shared wonder. Public events often include lectures by astronomers, telescope workshops, and even local festivals that celebrate the natural beauty of the universe. Many cultures also integrate key cosmic milestones into their traditional festivals and rituals. The winter and summer solstices, for instance, hold deep significance across various cultures. These celestial events, marking the shortest and longest days of the year, often inspire ceremonies and communal meals that honor the changing seasons and the sun's vital role in agricultural cycles. In some regions, large bonfires are lit during the winter solstice to symbolize the return of light after the darkest day, a tradition that speaks to humanity's perpetual hope in the face of darkness. As technology continues to shape how we experience and celebrate the cosmos, the digital age has provided new avenues for connecting people across the world. Through social media, individuals document and share their experiences of celestial events, creating a global conversation that transcends geographic and cultural boundaries. Whether through images, videos, or live-streamed observatory broadcasts, people are able to participate in cosmic occurrences in real time, even from the comfort of their homes. This virtual connection enables those unable to travel to distant observatories to still partake in these awe-inspiring moments, highlighting the power of technology to bridge vast distances. Beyond the realm of science, the universe has long served as a muse for artists, writers, and musicians. Many creative works have drawn inspiration from the beauty and mystery of the cosmos, offering a reflection of humanity's fascination with the stars. Paintings that capture the majesty of the night sky, songs that evoke the wonder of distant galaxies, and stories that explore the mysteries of black holes. All of these works of art speak to our shared experience of gazing up and contemplating our place in the vast universe. These artistic creations do more than just capture moments of beauty. They celebrate our collective curiosity and awe at the infinite expanse of space. At the heart of these cosmic phenomena lies the intricate dance of fundamental physical forces, which govern the behavior of everything from the formation of stars to the collapse of black holes. One of the most critical of these forces is gravity, the force that shapes galaxies, stars, and planetary systems. Described by Isaac Newton in his Laws of Motion, and later refined by Albert Einstein in his theory of general relativity, gravity acts as the architect of the universe. It dictates how matter attracts other matter and how space-time itself is warped by the mass of celestial bodies. The fabric of the cosmos is thus influenced and shaped by the force of gravity, guiding the formation and evolution of all structures in the universe. Another fundamental principle that governs cosmic events is the conservation of energy, which states that energy cannot be created or destroyed, only transformed. This law explains the life cycle of stars from their birth to their eventual death. As a star fuses hydrogen into helium in its core, it releases vast amounts of energy in the form of light and heat. This energy sustains life on planets like Earth, enabling the conditions necessary for life to thrive. However, when stars exhaust their nuclear fuel, they undergo dramatic transformations. The result can be spectacular phenomena like supernovae, where the release of energy is so intense it redistributes elements across the universe, contributing to the creation of new stars, planets, and even life itself. The principles of thermodynamics also play a crucial role in the evolution of stars and the fate of the universe. The second law of thermodynamics states that entropy, or disorder, tends to increase over time. This idea is fundamental in understanding the life cycles of stars. As stars age, the balance between energy generation and entropy shifts, leading to a gradual increase in disorder. The eventual heat death of the universe, a theoretical state where all energy is evenly distributed and no more work can be done, is one possible outcome of this thermodynamic process. The intricacies of these cosmic processes reveal a universe in constant flux, with stars and galaxies evolving toward ever more disordered states. In sum, the cosmic forces that govern the universe's most profound phenomena, from the birth of stars to the destruction of black holes, are deeply rooted in the fundamental laws of physics. These laws not only explain how celestial bodies form and evolve, but also shape our understanding of the cosmos as a whole. As we continue to explore these forces, we gain insights into the origins of the universe and the destiny of all that exists within it. Whether through technological advances, cultural celebrations, or scientific discovery, our fascination with the cosmos remains a driving force in humanity's quest for knowledge, connection, and exploration. Quantum mechanics introduces a profound layer of complexity to our understanding of the universe, particularly when we venture into the realm of extreme environments. In regions where gravity and density reach their peaks, such as black holes, the behavior of particles on the quantum level becomes a key player in shaping the fabric of cosmic phenomena. Here, the fundamental principles of physics, those governing the smallest particles, interact in ways that shape the very processes occurring within stars, neutron stars, and the most enigmatic objects in the cosmos. These interactions, intricate and profound, give rise to a vibrant tapestry of cosmic events that define not only the structure of the universe, but the very laws of nature that govern it. At the heart of the universe's story lies a series of monumental cosmic events, each offering a glimpse into the intricate dance of celestial forces. These events act as both historical markers and guides, leading scientists through the expansive narrative of the universe's evolution. When we observe phenomena such as supernovae, gamma-ray bursts, or galaxy collisions, we are not simply watching distant explosions or cosmic collisions. We are witnessing the underlying processes that shape the cosmos on every scale. Each of these spectacular events provides us with vital clues about the birth and death of stars, the formation of elements, and the intricate dynamics that govern galaxies and their interactions. Supernovae, for instance, represent one of the most dramatic cosmic occurrences, marking the explosive death of massive stars at the end of their life cycles. These cataclysmic explosions are not just the end of a star, but also the beginning of something far more expansive. Supernovae enrich the interstellar medium with heavy elements like iron and nickel, dispersing them throughout space. These elements are later incorporated into the formation of new stars, planets, and even life itself. By studying the light curves, the patterns of light emission, and the spectral signatures of supernovae, astronomers can not only learn about the chemistry of the universe, but also determine the distances to far-off galaxies. This, in turn, allows them to measure the expansion of the universe, shedding light on its age and the rate at which it is growing. The echoes of the ancient explosions guide us in our quest to understand the universe's origins and its ongoing transformation. Similarly, the collision of galaxies provides us with an awe-inspiring look into the forces that sculpt larger cosmic structures. These mergers are not merely spectacular events. They offer valuable insights into the formation and growth of galaxies over time. The gravitational forces at play during such collisions can trigger the birth of new stars, sometimes leading to the merger of supermassive black holes at the galactic centers. Such mergers also reveal the presence and influence of dark matter, an invisible yet influential force that governs the behavior of galaxies and the vast, unseen web of the universe. Studying these collisions helps astrophysicists refine their models of galaxy formation and evolution, offering crucial clues about the future of our cosmic neighborhood. Each galactic collision is a reminder that the universe is constantly in flux, with every collision and merger revealing a chapter in its long and winding history. In the broader context, these cosmic milestones are more than just fascinating spectacles. They serve as essential pieces of a cosmic puzzle. By analyzing the remnants and signatures left behind by these cataclysmic events, whether it's the radiation from a supernova or the gravitational waves rippling across space-time after a neutron star collision, astrophysicists can refine their models of stellar life cycles, galactic interactions, and even the nature of dark energy. Each discovery adds depth to our understanding of the cosmos, helping to build a comprehensive picture of how the universe has evolved over its 14 billion-year history. Moreover, these cosmic events provide a unique lens through which we can examine the fundamental forces of nature. Many of the most significant events in the universe involve conditions so extreme that they cannot be replicated here on Earth, offering scientists an unparalleled opportunity to study the interaction of gravity, electromagnetism, and nuclear forces under conditions far beyond our current experimental reach. Take, for example, the collision of neutron stars. When two neutron stars spiral towards each other and merge, they produce ripples in space-time, gravitational waves, that travel across the universe. By studying these waves, scientists are able to probe the very nature of gravity itself and test the predictions made by Einstein's theory of general relativity. These phenomena provide critical insights into the nature of space-time, gravity, and the fundamental forces that govern the universe. Such cosmic events also offer clues about the origins of the elements that make up the universe. During the rapid neutron capture processes that occur in neutron star mergers, heavy elements such as gold and platinum are forged in the extreme conditions of high-density environments. These processes provide a direct window into the workings of strong nuclear forces, shedding light on how elements are formed in the most extreme corners of the universe. Supernovae, too, play a crucial role in this cosmic synthesis, as the intense energy released during these stellar explosions enables the creation of elements like carbon, oxygen, and iron. These elements are not only vital for the formation of planets, but are the building blocks of life itself. By examining the light curves and spectra of these stellar explosions, astronomers can trace the path from the birth of stars to the creation of the elements necessary for life, deepening our understanding of both the cosmic and biological processes that intertwine to make life possible. In sum, the study of cosmic events provides an invaluable opportunity to explore the most fundamental questions about the universe. These events, often occurring under extreme conditions, allow scientists to test the limits of our knowledge about the forces that govern the cosmos. Through careful observation and analysis, we can not only gain a better understanding of the past and future of the universe, but also uncover the underlying principles of nature that govern everything from the tiniest particles to the grandest cosmic structures. As we continue to study the universe, these events will remain crucial guides in our journey to understand the vast and mysterious forces that shape the cosmos. Cosmic events offer a window into the fundamental nature of our universe, providing profound insights into the forces that shape our existence. Among the most enigmatic of these forces are dark matter and dark energy, which govern the behavior of galaxies and drive the universe's accelerating expansion. By studying the motion of galaxies and the phenomena of gravitational lensing, where light from distant stars bends around massive objects, scientists aim to unravel the mystery of these elusive forces. Each cosmic event is not just a fleeting occurrence, but a clue that deepens our understanding of the laws that govern the universe, raising even more questions that fuel the relentless pursuit of knowledge. To explore these mysteries, scientists employ innovative techniques to simulate cosmic events on Earth, allowing them to observe and experiment with conditions similar to those in space. One of the most prominent methods involves particle accelerators, colossal machines that can replicate the extreme conditions of the early universe by colliding particles at nearly the speed of light. These experiments offer a glimpse into the creation of matter following the Big Bang, providing essential clues about the fundamental particles and forces that shape our reality. In addition to particle accelerators, Astrophysicists also rely on sophisticated computer simulations to model a range of cosmic phenomena, including supernova explosions and the formation of galaxies. By processing vast datasets and using powerful algorithms, these simulations can replicate the intricate interactions of gravity and the behavior of celestial bodies across vast spans of time. These models allow scientists to study how galaxies collide, how black holes influence their surroundings, and even how entire cosmic structures evolve. Such simulations are invaluable in understanding the underlying mechanics that govern cosmic events and the interactions that define the structure of the universe. Beyond simulations, laboratories on Earth can recreate some of the extreme conditions found in space. For instance, high-energy lasers are used to simulate the intense heat and pressure of stars, or the extreme conditions found within neutron stars. These experiments help researchers understand nuclear reactions and the creation of heavy elements during stellar events, offering insights into the processes that occur during the death of massive stars. Geologists, too, play a vital role in simulating cosmic events, particularly through the study of ancient impact craters formed by asteroid collisions. By examining these craters, they can uncover how cosmic occurrences have impacted Earth's geology, and by extension, how life on our planet has been shaped by such forces. These multifaceted approaches, combining both theoretical models and experimental simulations, continue to push the boundaries of our understanding. Through them, scientists unlock the profound mysteries of the cosmos, shedding light on the events that shape the universe and, by extension, the potential for life within it. The life cycle of stars is one of the most remarkable examples of cosmic phenomena. Stars are born in vast clouds of gas and dust, known as nebulae. Over time, gravitational forces cause these clouds to collapse, clumping together and eventually igniting nuclear fusion. This marks the birth of a star, which begins its life cycle by emitting light and energy, shining brightly in the night sky. As stars age, they undergo several dramatic transformations. Smaller stars, like our Sun, will eventually expand into red giants, shedding their outer layers and forming a planetary nebula. The core left behind becomes a white dwarf, while the expelled material enriches the surrounding space with elements necessary for the formation of new stars and planets. Larger stars, however, meet a more dramatic end. They explode in cataclysmic supernova events, releasing an enormous amount of energy and scattering heavy elements like carbon, oxygen, and iron across the cosmos. These elements are the building blocks of planets and life itself, illustrating how the death of a star can lead to the birth of new stars and planetary systems. The remnants of a supernova can collapse into neutron stars or even black holes, while the shockwaves from the explosion can trigger the formation of new stars in nearby gas clouds. This interconnected cycle of stellar evolution is a reminder that each cosmic event, whether it's the birth of a star, its transformation into a supernova, or the creation of a neutron star, contributes to the dynamic fabric of the universe. As such, the life cycle of stars is intimately linked to the broader cosmic narrative. Each phase, from the birth of a star to its eventual death, serves as a cog in the machinery that drives the formation of galaxies, the creation of elements, and the evolution of the universe itself. This interconnectedness reveals a deeper truth about the cosmos, that the forces governing stellar evolution are not isolated phenomena, but part of a larger, ever-unfolding story that shapes the universe in profound and lasting ways. For those eager to engage with the cosmos, observing cosmic events offers a unique and awe-inspiring opportunity to witness these grand processes in action. Thanks to the proliferation of online resources, stargazing has never been more accessible. Websites dedicated to astronomy, such as those run by NASA and various planetariums, provide up-to-date schedules of celestial happenings, including meteor showers, eclipses, and planetary alignments. These sites offer detailed information about the timing and nature of these events, making it easier for enthusiasts to plan their observations and dive deeper into the wonders of the universe. The location from which you observe is also critical. To get the best view of cosmic events, it is essential to find dark, open areas far removed from the light pollution of cities. National parks and designated dark sky areas provide ideal settings for stargazing, offering unobstructed views of the night sky. However, for those who cannot travel to these locations, observing from a backyard or nearby park can still yield striking views, provided the area is free from artificial lighting. Technology plays an essential role in enhancing the stargazing experience. Smartphone and tablet applications now incorporate augmented reality to help users identify constellations, planets, and other celestial objects in real time. These tools can transform a casual observation into an immersive, guided experience, bringing the stars and planets to life in a way that engages both beginners and experienced astronomers. For those seeking a more interactive experience, local astronomy clubs and observatories often host public viewings during significant cosmic events. These gatherings provide not only an opportunity to observe, but also a chance to learn from experts and connect with others who share a passion for exploring the universe. Before embarking on a cosmic observation, however, it is essential to consider a few important factors. Understanding the nature of the event, whether it's a meteor shower, solar eclipse, or planetary alignment, is crucial, as each type of event has its own unique characteristics and requirements. Researching the event beforehand will provide insight into the best viewing times, the necessary equipment, and safety precautions, especially for events like solar eclipses, which require special eye protection. The right equipment can significantly enhance your experience. While many cosmic events are visible to the naked eye, binoculars or a telescope can reveal intricate details that would otherwise go unnoticed. Familiarizing yourself with local dark sky areas away from city lights is also important, as light pollution can significantly diminish the visibility of celestial events. Preparation, patience, and flexibility are essential virtues for any amateur astronomer. The weather may not always cooperate, and conditions can change rapidly, so keeping an eye on forecasts and being ready to adapt is key. By embracing these tools and techniques, anyone can embark on a journey of exploration, turning an ordinary evening into an extraordinary adventure through the cosmos. Whether through personal observation or participation in local stargazing events, each encounter with the universe offers a chance to connect with something far greater than ourselves. Arriving early to set up equipment and settle in is often the first step toward ensuring that you don't miss a single moment when an astronomical event kicks off. The early preparation helps to create a smooth experience, allowing you to be fully present when the first lights of the phenomenon appear. But that's just the beginning. Engaging with fellow astronomy enthusiasts can elevate the experience even further, transforming what could be a solitary pursuit into a shared adventure. The exchange of knowledge about the event itself, techniques for observation, and equipment can foster a vibrant sense of community and collective excitement. As discussions unfold, you may find yourself learning new ways to enhance your observation skills or gain insight into rare celestial occurrences. Networking, too, plays a significant role in deepening your connection to the world of astronomy. Engaging with local astronomy clubs or online forums opens up a wealth of resources, from expert tips to invitations for future events. These platforms create spaces for camaraderie, as well as a sense of belonging, which can make the journey of exploring the cosmos more enriching. Being well prepared, properly equipped, and open to sharing experiences with others not only makes observing a cosmic event more enjoyable, but adds layers of meaning that might otherwise be missed. Advancements in technology have fundamentally altered the way we interact with the universe, allowing us to explore the cosmos in ways that once seemed like science fiction. High-resolution telescopes, both on the ground and in space, now capture stunning images of celestial phenomena with unprecedented clarity. Instruments like the Hubble Space Telescope have allowed us to peer into distant nebula, star clusters, and the remains of supernovae, unveiling the awe-inspiring beauty and complexity of the universe. These technologies are not just about taking pictures. They're about revealing the fundamental truths of the cosmos, ones that have eluded humanity for centuries. Furthermore, the continuous evolution of data processing and analysis tools has accelerated our ability to make groundbreaking discoveries. Sophisticated algorithms sift through enormous datasets, helping us identify patterns that might otherwise go unnoticed. These advancements have enabled us to find exoplanets in distant solar systems and to detect gravitational waves, ripples in space-time caused by cosmic collisions, shedding light on the most mysterious and elusive phenomena in the universe. The ability to instantly share these discoveries with researchers, scientists, and astronomy enthusiasts around the world fosters an environment of collaboration, sparking renewed interest in scientific inquiry and expanding the frontiers of knowledge. The rise of digital platforms has democratized access to cosmic events in ways that were previously unimaginable. Now, people across the globe can tune into live streams of solar eclipses, meteor showers, and comet appearances, connecting in real time with these fleeting but spectacular phenomena. Social media has further revolutionized this dynamic, allowing amateur astronomers to share their observations and images with a wider audience. This sense of global interconnectedness creates a vibrant and supportive community where the passion for astronomy grows exponentially, inspiring a new generation of skywatchers. But technology doesn't only enhance our visual experiences. It has also revolutionized our auditory relationship with the cosmos. Instruments capable of converting cosmic signals into sound offer us the unique opportunity to hear the universe. These sounds, often imperceptible to the human ear, transform abstract data into something tangible and creative. For many, this new form of engagement with the cosmos sparks curiosity and wonder, adding a new dimension to the way we understand space and time. As technological innovations continue to grow, our relationship with the cosmos will undoubtedly deepen, enriching not only our scientific understanding, but also our cultural connection to the universe around us. This ever-expanding partnership with technology is transforming the act of stargazing into something far more immersive, inviting people of all ages to partake in the mysteries of space in ways that were once the domain of a select few. To observe the wonders of the universe, there are several key tools that dramatically enhance our ability to experience celestial events. Telescopes are at the forefront of these instruments, enabling both enthusiasts and scientists to peer into the farthest reaches of space. There are various types of telescopes, each suited to different purposes. Optical telescopes, which gather visible light, allow us to observe everything from nearby planets to distant galaxies. Radio telescopes, on the other hand, capture radio waves, revealing a different layer of information about the cosmos, including phenomena that are invisible to the naked eye. For those who may not have access to a telescope, binoculars offer an accessible alternative, providing a wide field of view that's ideal for observing bright celestial events such as meteor showers or planetary alignments. With the help of binoculars, even the casual observer can easily spot stars, planets, and other wonders of the night sky, making astronomy an activity that anyone can enjoy, regardless of expertise. For more focused observations, especially when tracking dynamic events like eclipses or transits, solar filters or eclipse glasses are essential. These specialized tools protect the eyes from the intense glare of the sun, allowing safe viewing of solar phenomena. Solar telescopes equipped with these filters take things further, enabling us to observe detailed solar activity, such as sunspots and solar flares. These observations help us understand not only the sun's behavior, but also its significant impact on the entire solar system. In addition to these physical tools, the rise of digital applications and websites dedicated to astronomy has further enriched the experience. These platforms provide real-time data on celestial events, offer star maps, and even suggest the best times and locations for optimal viewing. This technological integration makes it easier than ever for anyone to engage with the cosmos, from novice skywatchers to seasoned astronomers. The thrill of observing a celestial event is further amplified when communities come together to share the experience. Events like star parties, gatherings held in parks or public spaces where people bring their telescopes and binoculars to witness astronomical phenomena, create an atmosphere of shared wonder and discovery. These gatherings foster a sense of unity, where individuals can socialize, exchange knowledge, and learn from one another. Star parties are a perfect example of how astronomy can bring people together, bridging differences and creating a common bond through the fascination with the night sky. When we gather as a community to observe the cosmos, we not only enrich our understanding of the universe, but also deepen our collective appreciation for the mysteries that lie beyond our world. By coming together to witness these extraordinary events, we forge connections that will inspire curiosity and wonder for generations to come. The journey to explore the stars is not a solitary one. It's a shared adventure, and every discovery is an invitation to be part of something much larger than ourselves. In today's world, schools and community centers hold a unique opportunity to inspire curiosity and excitement about the cosmos. By organizing educational programs focused on upcoming celestial events, such as meteor showers, eclipses, or planetary alignments, these institutions can cultivate a profound sense of wonder. These programs might include lectures, interactive workshops, or hands-on activities designed to prepare participants for what they can expect during these awe-inspiring events. Through this preparation, individuals are more likely to feel a connection to the event itself, increasing their enthusiasm and deepening their engagement when the moment arrives. Whether it's a community coming together to watch a meteor streak across the sky or gathering for an eclipse, these shared experiences offer a unique way to connect to something much larger than ourselves. Moreover, the role of social media in fostering communal enthusiasm cannot be overstated. In our increasingly digital world, platforms such as Facebook, Instagram, and Twitter serve as modern meeting grounds for stargazers and astronomy lovers alike. Event pages or online groups offer a space for people to plan their observations, share tips, and even coordinate outings to remote locations where light pollution is minimal. These virtual spaces not only provide real-time information, but also help build a sense of community among local enthusiasts, enabling them to connect, collaborate, and, in some cases, even travel together to places with better visibility. Such online interactions encourage people to share their experiences and knowledge, creating a network of support and enthusiasm that can make every celestial event feel like a communal celebration. Additionally, partnerships with local astronomical societies or observatories can elevate these gatherings, turning them from simple stargazing meetups into educational and immersive experiences. Imagine an evening where experts guide attendees through the wonders of the night sky, explaining the science behind each phenomenon. By offering expert-led observations and providing deeper insights into the mechanics of celestial events, these partnerships enrich the communal experience. Not only does this foster a greater appreciation for the universe, but it also cultivates a deeper understanding of the forces that govern our existence. This collaboration between local institutions and the community enhances the learning experience, inspiring a sense of awe and connection to the cosmos. At the same time, documentaries have the power to capture the imagination and curiosity of audiences, making celestial events accessible and exciting. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the moon, and the sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By framing these vast and often incomprehensible phenomena in relatable terms, documentaries can spark a sense of wonder and intrigue in viewers. For example, when covering events like solar eclipses, filmmakers can use visuals to illustrate the intricate dance between the Earth, the Moon, and the Sun, showing how such celestial alignments have profound implications for life on Earth. By making these phenomena accessible to the audience, documentaries help bridge the gap between abstract scientific concepts and everyday life. Visual storytelling plays an essential role in this process, with animations and graphics serving as tools that make complex ideas easier to understand. Whether it's a stunning graphic of a supernova's explosion or a visual representation of the birth of a star, these images bring to life the processes that occur in the cosmos. With the right blend of scientific detail and artistic representation, documentaries can translate dry, abstract data into something that both educates and entertains. For instance, showcasing the creation of elements within a supernova not only illustrates the scale of the event, but also highlights how these cosmic explosions are vital to the formation of the elements necessary for life on Earth. Another powerful storytelling technique is the inclusion of expert interviews combined with personal anecdotes from people who have witnessed these celestial phenomena. Hearing directly from scientists who study the cosmos alongside individuals who have seen the events firsthand adds a human dimension to the science. This approach allows viewers to understand not only the mechanics behind the phenomena, but also the emotional and cultural impact these events have had on humanity throughout history. When people hear personal stories about moments of awe inspired by the cosmos, it brings the science down to earth, making it feel more tangible and less abstract. Finally, connecting celestial events to current global challenges can give these occurrences a deeper, more practical significance. By highlighting how astronomical research can inform our understanding of climate patterns, for example, documentaries can show how cosmic events are not just distant and irrelevant phenomena, but rather events that can enhance our understanding of Earth's environment. For instance, understanding how the Earth's orbit and position in relation to the Sun can influence long-term climate patterns helps scientists predict natural disasters. This connection between the cosmos and our daily lives provides a powerful narrative that makes the study of celestial events not only fascinating, but also deeply relevant to the world we live in. Through visual storytelling, filmmakers can take these often abstract, hard-to-grasp scientific concepts and make them tangible for viewers. These visuals serve as a bridge, transforming complicated ideas into experiences that provoke curiosity, wonder, and awe. Whether depicting the enormity of the universe or the intricacies of a black hole, visuals allow us to see the unimaginable. In doing so, they invite us into the vastness of the cosmos and deepen our understanding of the processes that govern it. In the case of black holes or the formation of stars, advanced animation can reveal the beauty and complexity of these phenomena. These artistic renditions not only educate viewers about the scientific principles at play, but also offer an emotional connection to the events. By watching the life cycle of a star unfold from its birth to its eventual death, viewers gain a new understanding of how stars shape the very fabric of the universe. These visualizations help people appreciate the scale and interconnectedness of the cosmos, revealing how even the most distant events have an impact on our understanding of life and the universe as a whole. In essence, through a combination of educational programs, community engagement, social media, expert involvement, and captivating visual storytelling, celestial events become more than just astronomical phenomena. They become opportunities for shared learning, collective excitement, and a deeper understanding of the universe's role in shaping our world. Whether through documentaries that merge science and emotion, or through community gatherings that bring people together under the night sky, these experiences offer a powerful reminder of the vast interconnected cosmos that surrounds us. In the realm of storytelling, the synergy between sound and visuals holds an undeniable power. When paired carefully, these elements elevate the narrative, amplifying its emotional resonance. A thoughtfully crafted soundtrack has the ability to evoke emotions that mirror the visuals on screen, enriching the audience's experience and fostering a deeper connection to the content. This is especially true in documentaries that explore the vastness of cosmic themes. When breathtaking visuals of the universe are combined with a well-structured narrative, they create a multisensory experience, one that doesn't simply inform, but immerses. This potent combination of audiovisual elements not only enhances the aesthetic appeal, but also encourages viewers to see the universe in a more personal light, sparking a curiosity that might lead to a greater interest in scientific discovery and exploration. Visual storytelling, however, is far more than an accessory to the narrative. It is a fundamental tool that shapes how we convey knowledge and understand the mysteries of the universe. The complexities of scientific phenomena, which might otherwise be beyond our grasp, are made accessible and engaging through carefully designed visuals. These visuals act as bridges, transforming abstract and intricate scientific concepts into something that feels tangible, relatable, and human. By making the invisible visible, visual storytelling offers audiences a new lens through which they can perceive the universe, a cosmos that, in its vastness, might otherwise seem remote and incomprehensible. Through this lens, audiences are not merely spectators. They are invited into a world that inspires awe, curiosity, and an unyielding desire to explore further. Effective documentaries that delve into cosmic themes rely on a process of simplification and translation. Complex scientific ideas are deconstructed into digestible segments, often through clear, vivid visual representations that highlight key processes and phenomena. A good documentary doesn't just present the facts, it builds a narrative, weaving those facts into a story that captivates and educates. It is in this narrative that viewers develop an emotional connection to the material. For instance, animations can bring to life the birth of stars, demonstrating processes that are otherwise invisible to the naked eye. At the quantum level, where particle interactions occur beyond the reach of traditional observation, animations help illustrate these processes in a way that is both understandable and visually stimulating. The language used to communicate these scientific ideas also plays a critical role in this journey of discovery. Clarity is essential when translating complex topics into a language that anyone can grasp. While technical jargon is inevitable, the key lies in finding the balance, ensuring that such terms are well defined without dumbing down the science. A documentary that thrives will never sacrifice accuracy for simplicity, yet it recognizes the importance of making that accuracy accessible. It may even rely on metaphors and analogies, using relatable comparisons to ease the viewer's understanding. A common example is the comparison of an atom's structure to a miniature solar system, a familiar image that serves to contextualize an otherwise alien concept. Interviews with scientists, astronomers, and experts are indispensable to the storytelling process. Their voices add credibility and depth to the narrative, offering first-hand insight into the research, the challenges, and the moments of discovery that shape our understanding of the cosmos. These interviews don't just serve as data points, they humanize the science, allowing viewers to connect with the people behind the discoveries. When scientists share their passion for their work, it injects the documentary with a sense of urgency and excitement. It becomes more than a lecture on the universe. It becomes a conversation between the audience and the experts, a chance to witness the wonder that fuels scientific inquiry. Through this blend of sound, visuals, language, and expert commentary, documentaries about space and the cosmos don't just inform, they engage. They create a narrative that viewers can connect with on both an intellectual and emotional level. The curiosity they ignite doesn't just serve to answer questions, it serves to deepen the mystery, inviting viewers to continue exploring, to look up at the stars with renewed wonder and a burning desire to understand the universe's complexities. In the end, these documentaries do more than just explain the cosmos. They inspire a lasting journey of discovery. In documentary filmmaking, pacing plays an essential role in maintaining an engaging rhythm that balances the delivery of information and visual elements. The delicate art of pacing ensures that viewers remain captivated, guiding them through complex concepts without overwhelming them. A seamless transition between segments is crucial, allowing the narrative to evolve naturally. The result is a journey through increasingly intricate scientific ideas that don't confuse the audience, but instead invite them to dive deeper into the subject matter. By carefully constructing the flow, filmmakers ensure that even the most sophisticated scientific concepts resonate with a wide range of viewers. This approach fosters a profound appreciation for the complexities and wonders of science, making it more accessible and enjoyable for all. Filmmakers who tackle the awe-inspiring task of representing cosmic events face a unique set of challenges. One of the most formidable hurdles they encounter is the sheer scale of space itself. The universe is so vast, so mind-bogglingly enormous, that conveying its true scale in a way that audiences can grasp is an endeavor in itself. For example, when depicting the birth of stars or the dramatic collision of galaxies, filmmakers must strike a delicate balance. They need to present the breathtaking visual grandeur of these events without distorting the scientific realities that govern them. It's about capturing the majesty of the cosmos while remaining true to the actual phenomena that take place. Another significant challenge is how to represent time itself. The processes of the universe unfold over enormous stretches of time, millions, even billions of years. Yet, in a film's narrative, time must be condensed into more manageable moments. This compression of time, essential for maintaining the pacing of the story, presents a dilemma when dealing with vast cosmic events. Take, for instance, the formation of a planetary system. Filmmakers need to distill eons of planetary evolution into just a few minutes of screen time, ensuring that viewers still get a sense of the complexity and wonder behind these processes. Achieving this requires not only an artistic eye, but also a profound understanding of astrophysics. The result is an engaging visual experience that remains grounded in scientific fact. Technological limitations are another obstacle filmmakers must contend with. While advances in computer-generated imagery, CGI, have revolutionized the creation of stunning visual effects, there are still immense challenges when it comes to accurately simulating phenomena like black holes or supernova. These cosmic events are not just visually spectacular, they're scientifically complex, and representing them authentically requires an intimate understanding of the underlying physics. Despite impressive CGI advancements, filmmakers must tread carefully to avoid exaggerating or oversimplifying these phenomena for the sake of spectacle. There's always a risk that the pursuit of visual impact might overshadow scientific accuracy, and it's a delicate balance to strike. Collaboration between filmmakers and scientists becomes crucial in overcoming these hurdles. By working hand in hand with astrophysicists, cosmologists, and other scientific experts, filmmakers can ensure that their depictions of cosmic events are as accurate as possible. This partnership is more than just an exchange of information. It leads to a richer narrative, where the awe of the cosmos is matched by the scientific integrity of the facts. Experts help ground the narrative, making it not only visually captivating, but also intellectually enriching. The ultimate goal is to ignite curiosity about the universe while staying true to the fascinating scientific principles that define it. Incorporating experts into the documentary process provides invaluable insight into complex phenomena. These scientists possess years of research, fieldwork, and direct observation, which enable them to break down the most difficult concepts into language that is accessible to the general public. They can shed light on mysteries like black holes, supernovae, and cosmic microwave background radiation, offering context that helps viewers see how these events fit into the larger cosmic tapestry. By placing these occurrences within the framework of current scientific understanding, they make it easier for audiences to grasp their significance in the grander scheme of the universe. Experts also lend credibility to the narrative. Their deep knowledge and experience give authority to the film's content, reassuring viewers that what they're seeing is both scientifically sound and carefully researched. Moreover, these experts often share first-hand experiences that add a human touch to the story. Whether recounting the exhilarating moments of witnessing a total solar eclipse or recounting the process of collecting data on a space mission, these personal stories create an emotional connection between the audience and the science behind the spectacle. These moments ground the abstract science in tangible human experience, enriching the documentary's impact. Furthermore, experts are adept at addressing misconceptions that often surround complex scientific phenomena. For instance, many viewers may still hold myths or misunderstandings about what a black hole truly is. Through clear explanations, experts can dispel these myths and clarify the realities of such enigmatic cosmic objects. Their ability to anticipate viewer questions and provide answers before confusion arises makes the documentary more engaging and informative. This ensures that the content resonates not just with casual viewers, but also with those who are already enthusiasts, deepening the overall experience for everyone. By weaving together the scientific accuracy of experts, the artistry of filmmaking, and the awe-inspiring scale of the cosmos, a documentary can become much more than just a visual spectacle. It becomes a bridge between the public and the mysteries of the universe, fostering a deeper understanding and appreciation of the forces that shape our existence. Through careful pacing, expert collaboration, and an unwavering commitment to scientific truth, these films can spark wonder and curiosity, inviting viewers to see the universe in a whole new light. As humanity stands on the threshold of unprecedented discoveries, the future of cosmic exploration has never been more exciting. Experts now find themselves at the forefront of a new era, where technological advancements unlock the mysteries of the universe and inspire fresh visions of what lies ahead. These pioneers are not only discussing the next frontier of space exploration, but also the profound implications these discoveries will have on humanity's place in the vast expanse of the cosmos. Through their insights on upcoming missions and groundbreaking theories, they are igniting a sense of wonder, encouraging us all to imagine a future filled with possibilities yet to be uncovered. Astronomy, once a field confined to the exploration of distant stars and galaxies, has transformed into a dynamic and constantly evolving discipline. With each new discovery, we gain a deeper understanding of the universe, and the role of technology in this journey is nothing short of revolutionary. The advent of advanced instruments and powerful observational tools has opened new windows into the cosmos, allowing astronomers to peer into the very heart of distant galaxies, uncover hidden exoplanets, and examine celestial phenomena in unparalleled detail. This level of precision has completely reshaped our approach to understanding space. One of the most significant strides in astronomical technology has been the construction of telescopes with much higher resolution and the establishment of space-based observatories. These innovations have exponentially improved our ability to observe and analyze phenomena that were once beyond our reach. The ability to study distant galaxies and exoplanets with such clarity leads to a cascade of new questions, each discovery propelling the field forward and demanding new methodologies and refined theories. Astronomers now find themselves at the intersection of multiple disciplines, collaborating with physicists, chemists, and even biologists to form a more holistic understanding of the cosmos. The detection of gravitational waves, first achieved in 2015, stands as one of the most groundbreaking moments in this interdisciplinary approach. These ripples in space-time, first predicted by Albert Einstein's theory of relativity, have provided new avenues of research, blending astrophysics with the principles of relativity. With each new detection, we learn more about the most extreme cosmic events, like black hole mergers or neutron star collisions that were previously invisible to us. This fusion of disciplines continues to drive scientific inquiry, refining the questions we ask and expanding the tools we use to seek answers. Yet perhaps one of the most exciting frontiers in cosmic exploration lies in the search for extraterrestrial life. The discovery of exoplanets orbiting distant stars has sparked intense interest in understanding the conditions necessary for life. Astronomers, together with astrobiologists, are now focused on identifying planets that reside in the habitable zone of their stars, where liquid water could exist. With increasingly sophisticated techniques like transit photometry and spectroscopy, scientists can study the atmospheres of these far-off worlds, searching for biosignatures that might hint at life beyond Earth. Alongside these professional endeavors, a revolution in citizen science is taking place. Amateur astronomers from all over the globe are playing an essential role in advancing our knowledge of the universe. By participating in collaborative projects that analyze data from space missions, they are making meaningful contributions to the field. This democratization of science not only accelerates the pace of discovery, but also fosters a broader public interest in astronomy. Through citizen science, we witness how astronomy adapts and thrives in the face of new technologies and discoveries, shaping a future where science is truly a collective endeavor. As we look to the future, the ongoing evolution of astronomy reflects humanity's deep desire to unravel the mysteries of the cosmos. Each breakthrough opens doors to new areas of research, pushing us ever closer to understanding the universe's most profound questions. Several emerging technologies promise to transform our understanding of cosmic events even further, particularly through advancements in observational techniques and computational power. Among the most eagerly anticipated innovations are the next-generation gravitational wave detectors. Instruments like the Laser Interferometer Space Antenna, LISA, a space-based observatory designed to detect gravitational waves, hold the promise of observing phenomena that are currently beyond our reach. By detecting ripples in spacetime, LISA will allow scientists to observe events like black hole mergers or neutron star collisions, providing insights into some of the most violent and enigmatic processes in the universe. This ability to study previously invisible events will enhance our understanding of the fundamental forces that shape the cosmos. In parallel, the next generation of telescopes is poised to offer an even deeper view of the universe. The James Webb Space Telescope has already begun its mission to push the boundaries of cosmic observation, enabling researchers to study the formation of distant galaxies in unprecedented detail. Building on its successes, large-scale ground-based observatories like the Extremely Large Telescope ELT and the 30-meter telescope TMT will take our observational capabilities to new heights. These observatories will allow scientists to collect vast amounts of data on the atmospheres of exoplanets and the origins of cosmic structures, potentially revealing new insights into the conditions that foster life beyond Earth. But it's not just observational advancements that are driving the future of astronomy. The integration of artificial intelligence, AI, and machine learning is set to revolutionize the way we analyze and interpret astronomical data. With vast amounts of data pouring in from space missions and telescopes, human researchers would be overwhelmed by the sheer volume. AI algorithms, however, can sift through this data far more efficiently, identifying patterns and anomalies that might otherwise go unnoticed. This capability will enhance our understanding of a range of cosmic events, from supernova explosions to the mysterious dynamics of dark matter. As these technologies continue to advance, our capacity to study the universe will grow exponentially. The increasing wealth of data collected by astronomers will require new, innovative methods of analysis, methods that AI is poised to provide. This intersection of cutting-edge technology and human curiosity will fuel a new age of discovery, one that will shape our understanding of the cosmos for generations to come. Through these advancements, we may find ourselves closer than ever to answering some of the most profound questions humanity has ever asked. Are we alone in the universe? What lies at the heart of a black hole? How did the universe come into existence? With every new discovery, we move a little further into the unknown, yet each step brings us closer to understanding our place in the cosmos. The future of cosmic exploration is bright, and as technology continues to evolve, the wonders of the universe will undoubtedly become even more accessible, inspiring future generations to keep exploring the stars. The dawn of quantum computing has unlocked a realm of possibilities that could revolutionize our understanding of the universe. This new era promises to explore cosmic phenomena in ways previously beyond our grasp. Quantum computers have the potential to simulate processes in the cosmos with an accuracy and precision far surpassing that of classical machines, enabling the modeling of everything from the smallest particle interactions to the vast evolution of the universe itself. As quantum technologies continue to evolve, their synergy with other scientific advances may soon shed light on some of the most profound mysteries of our existence. These breakthroughs could forever change the way we perceive reality, inspiring future generations to reach for new heights in scientific discovery. The potential for quantum computing to simulate the universe at a level of precision previously thought impossible could offer unprecedented insights into the fundamental workings of nature. By simulating interactions between subatomic particles or mimicking the behavior of cosmic systems, quantum computers may reveal the intricate, hidden mechanisms that govern the cosmos. From understanding the formation of galaxies to predicting the behavior of black holes, the applications are vast. What we are witnessing is not just a technological advancement, but the beginning of a new era in cosmic exploration. However, this is not a journey that can be undertaken by a single nation or institution. The future of astronomical exploration hinges on international collaboration, where scientists from all corners of the world unite in their pursuit of knowledge. By sharing resources, expertise, and diverse perspectives, these global partnerships are pushing the boundaries of what can be achieved in space exploration. The Event Horizon Telescope, a historic collaboration that captured the first ever image of a black hole, stands as a testament to the power of such cooperation. This groundbreaking achievement would have been inconceivable without the joint efforts of astronomers, engineers, and technicians across the globe. When nations come together, they create opportunities for ambitious, large-scale projects that would be impossible to undertake alone. Global collaborations enable the pooling of financial resources, technological infrastructure, and human expertise, which accelerates progress and fosters innovation. Observatories scattered around the world, working in tandem, can capture simultaneous data on celestial events, providing a much broader and more nuanced understanding of phenomena such as supernovae and gravitational waves. This interconnectedness not only strengthens the scientific community's ability to confirm and validate findings, but it also opens the door to new methods of inquiry and discovery. Diverse cultural perspectives bring fresh solutions to age-old problems, sparking new avenues of research that might otherwise have been overlooked. The benefits of international collaboration in astronomy extend beyond the scientific realm. Working together enables countries to overcome financial and resource constraints that often limit the scope of individual efforts. By sharing the financial burden, nations can invest in cutting-edge technology and facilities that would be out of reach on their own. This collective approach ensures that research efforts remain sustainable and that the pace of discovery is continually accelerated as the scientific community embarks on the most ambitious quests in the history of human exploration, such as understanding dark matter, searching for extraterrestrial life, or studying the future of our planet. The importance of these global partnerships will only grow. As we look to the future, the need for continued international cooperation in space exploration will become even more crucial. The mysteries of the universe are vast, and the tools needed to unlock them will require the combined efforts of a global scientific community. Whether unraveling the secrets of distant galaxies or investigating the fundamental nature of space and time, these collaborations will be the key to advancing our understanding of the cosmos and our place within it. Together, nations will expand the horizons of scientific discovery, enriching humanity's collective knowledge and providing solutions to the challenges we face as a species. In parallel with these technological advancements, space agencies are discovering innovative ways to engage the public in the wonders of the universe. One of the most impactful strategies has been the use of live streaming technology to broadcast cosmic events in real time. Events like solar eclipses, meteor showers, and planetary transits are now accessible to people across the globe. offering them a front row seat to the majesty of the universe. These broadcasts, often accompanied by expert commentary, demystify the complex phenomena of the cosmos, allowing audiences to experience the wonder of the universe as it unfolds. This connection fosters a deeper appreciation for science and can inspire individuals to pursue their own scientific curiosity. Educational outreach initiatives have also become a cornerstone of public engagement. Space agencies and scientific organizations are increasingly focusing on teaching astronomy in schools and community centers through hands-on workshops and interactive activities. By providing materials that make complex concepts easier to understand, these initiatives help spark curiosity and inspire a love for science in younger generations. When students and community members participate in activities like building their own models of the solar system or tracking the movement of celestial bodies, they gain a sense of ownership over their learning experience. This not only enriches their understanding, but also encourages them to think critically about the world around them. Moreover, social media platforms have proven to be an invaluable tool for connecting with a broader audience. Through captivating visuals, interesting facts, and real-time updates about celestial events, space agencies can engage millions of people worldwide. By creating shareable content that resonates with diverse audiences, these agencies foster a global community of astronomy enthusiasts. This online engagement is especially effective with younger generations who predominantly consume information via digital platforms. The ability to participate in live discussions or share in the excitement of cosmic discoveries enhances the sense of belonging within this community, making science more accessible and relatable to all. In sum, the intersection of technology, international cooperation, and public engagement forging a new era in the exploration of the cosmos. As we venture further into the unknown, these combined efforts will be instrumental in unraveling the mysteries of the universe, inspiring generations to come, and expanding our collective understanding of the vast and awe-inspiring cosmos we call home. To truly understand the grandeur of the universe, one must delve into the remarkable cosmic events that shape the fabric of reality itself. These events, ranging from the explosive birth of stars to the mysterious pull of black holes, captivate our imagination and stir profound questions. As humanity continues to explore these celestial phenomena, collaborations with institutions such as museums, planetariums, and local organizations play a pivotal role in amplifying public engagement with the cosmos. By hosting events in easily accessible public spaces, agencies have the opportunity to offer individuals a chance to gather, share knowledge, and learn collectively. Such initiatives create an immersive environment where people can celebrate the wonders of the universe. With live demonstrations, expert-led talks, and interactive displays, these events foster a lively atmosphere that sparks curiosity and excitement. They become more than just educational endeavors. They turn into communal celebrations of exploration and discovery, nurturing a collective passion for understanding the vastness of the cosmos. Yet, as humanity takes bold steps into the cosmos, the exploration of these celestial phenomena raises important ethical questions that demand careful thought and rigorous discussion. One of the most pressing issues is the potential impact of our activities on future generations. As we study and in some cases manipulate celestial bodies and forces, we must consider the long-term implications for our planet and its inhabitants. The pursuit of knowledge should never come at the expense of the well-being of future generations. Moreover, balancing the thirst for discovery with our responsibility to protect the Earth's environment is essential. With the rise of emerging technologies, some with unforeseen consequences, we are presented with a unique challenge to advance our understanding of the universe while safeguarding the delicate ecosystems that sustain life on Earth. This balance requires a keen awareness of the possible ripple effects our actions could have on the planet's health, as well as on the ethical and moral considerations that guide scientific exploration. Another critical ethical dimension revolves around the accessibility of information and resources in space exploration. The cosmos is not just a scientific domain, it is the shared heritage of all of humanity. However, as technological advancements accelerate, there is a risk of deepening the divide between nations or organizations that possess the resources to engage in cutting-edge research and those that do not. To ensure that the fruits of cosmic discovery benefit all of humankind, it is imperative that knowledge and technology be shared equitably. Collaboration and open communication among the global scientific community are not just desirable, they are essential for fostering a more inclusive future. Furthermore, as missions to distant celestial bodies are no longer relegated to the realm of science fiction, the topic of planetary protection comes to the forefront of space exploration. This involves safeguarding both Earth's biosphere and the environments of other planets from contamination. The scientific community strongly advocates for policies that prevent the introduction of earthly microorganisms into extraterrestrial ecosystems, as such contamination could disrupt potential life forms and obscure our understanding of life's development elsewhere in the universe. In addition to these considerations, there are existential risks that demand attention. As we develop more powerful technologies for space exploration, we must reflect on their potential to alter not only the course of our civilization, but the very fabric of reality itself. The theoretical implications of artificial intelligence in space exploration, or the potential weaponization of space technologies, pose serious threats that must be addressed before they are realized. These discussions are not merely academic, they are part of a broader dialogue about our place in the universe and the responsibilities we bear as stewards of both Earth and the cosmos. While audiences are often mesmerized by the spectacular nature of cosmic events like supernovae and black holes, many pertinent questions go unanswered. One such question focuses on the long-term effects of these events on the surrounding environments. For instance, when a star explodes in a supernova, the debris it emits plays a crucial role in the formation of new stars and planetary systems. Viewers may wonder how frequently such events occur and what their implications are for the resources and materials within our galaxy. The aftermath of these cosmic occurrences has the potential to reshape the structure of galaxies, influencing the future of star formation and the distribution of elements necessary for life. Another frequently asked question revolves around the possibility of life emerging in the wake of such cosmic events. When massive stars reach the end of their life cycles and explode, they create elemental materials that form the building blocks for planets, and potentially for life itself. Audiences are naturally intrigued by the idea that these new environments could foster the conditions necessary for the emergence of living organisms. How do these monumental transformations shape the future of celestial bodies, and what implications do they hold for the ongoing story of life in the universe? Perhaps even more mind-boggling is the effect of cosmic events on the fabric of space-time itself. When black holes consume matter, they warp the very dimensions of space around them, creating bizarre and fascinating phenomena, such as gravitational waves. These waves ripple through the cosmos, stretching and compressing space-time in ways that challenge our understanding of the universe on both cosmic and local scales. People are often fascinated by how these disruptions affect our perception of reality and how they might alter our theories about the nature of space, time, and gravity. As these cosmic events continue to stir the curiosity of audiences, they also serve as reminders of the incredible complexity and interconnectedness of the universe. The pursuit of knowledge about these events not only deepens our understanding of the cosmos, but also encourages us to ask fundamental questions about the origins of life, the nature of existence, and our place within the vast expanse of space. The cosmos, vast and ever-changing, has long captivated the human imagination. But how do we truly perceive the cosmic wonders unfolding across the universe? The interplay of light, space, and distance can create a complex tapestry of experiences, making a celestial event appear vastly different depending on your vantage point. For example, an astronomical occurrence witnessed from Earth may look entirely different when observed from a nearby star system. This stark contrast prompts significant questions about the nature of observation itself and how the different perspectives across space can deepen our understanding of the universe. By delving into these often overlooked questions, we not only explore the mechanics of cosmic phenomena, but also reflect on our place in this expansive universe. In today's world, social media platforms have become crucial in sparking excitement about upcoming celestial events. Meteor showers, eclipses, and planetary alignments have all been brought to the forefront of public consciousness, thanks to the visually striking images and videos shared online. These platforms have transformed the way we engage with the cosmos, offering organizations, enthusiasts, and even casual observers a chance to share captivating visuals and compelling narratives that capture the imagination. The stunning photographs of celestial phenomena, whether they depict dazzling meteor showers or distant galaxies, ignite curiosity and inspire viewers to participate in or simply observe these events. Furthermore, interactive elements like live streams and real-time countdowns have added a new dimension to the viewing experience, increasing the level of engagement among followers. The thrill of witnessing a cosmic event in real time while joining a global community of like-minded observers is something that social media amplifies to its fullest. During these events, hosts can provide expert commentary, share tips on how to best view the spectacle, and answer questions from curious viewers. This makes the experience more than just a passive observation. It becomes a shared journey. Moreover, user-generated content further enriches the discourse around these events. Individuals from all over the world, through photos, videos, and personal experiences, contribute their unique perspectives to the conversation. This collaborative sharing fosters a deeper connection between the universe and the people observing it, building anticipation and excitement in the lead-up to the event. It's no longer just about witnessing a cosmic event, it's about being a part of a global celebration. Targeted campaigns on social media are increasingly designed to engage specific demographics, whether young adults, students, or science enthusiasts. By tapping into trending hashtags and collaborating with influencers in the science and space communities, organizations can significantly expand their reach. This strategy not only reignites the interest of seasoned astronomy enthusiasts, but also opens up the wonders of the cosmos to newcomers. These social media movements, fueled by viral content and high-quality outreach, bring the universe closer to millions of people who may have never previously considered looking up at the night sky. For educators and science communicators, social media presents an unprecedented opportunity to make astronomy more accessible. Through tutorials, articles, infographics, and interactive content, they can help demystify complex astronomical concepts and engage a wider audience. By offering easily digestible information about what to expect during celestial events, these experts empower people with knowledge. This, in turn, sparks curiosity and passion for the subject. The integration of education and accessibility on these platforms has the potential to transform casual observers into enthusiastic participants, fostering a deeper and more lasting appreciation for the universe. Beyond the posts and live streams, interactive tools can amplify the experience of exploring cosmic events. Imagine a documentary that not only tells the story of a celestial event, but also offers the audience the chance to actively engage with the content. This can include everything from digital maps that chart the movement of stars and galaxies to augmented reality applications that bring celestial bodies right into your living room. For example, by using a smartphone or tablet, viewers could visualize a supernova explosion as though it were happening in their own space, creating an immersive experience that makes the scale and beauty of the universe feel tangible and real. Educational games that simulate space exploration offer another innovative way to engage audiences. These interactive activities allow participants to assume the role of astronomers, solving problems, making decisions, and exploring the cosmos in ways that textbooks and traditional documentaries cannot match. These activities encourage critical thinking and problem solving while deepening the understanding of space exploration. As we continue to embrace the digital age, the possibilities for engaging with the cosmos through interactive, educational, and immersive experiences are endless. What once seemed like distant, abstract phenomena now feels accessible and personal. Through social media, augmented reality, and educational tools, we are bringing the universe to our fingertips, expanding our understanding and deepening our connection to the cosmos in ways we could never have imagined just a few decades ago. Virtual reality experiences have the potential to revolutionize how we interact with the cosmos, providing users with the opportunity to immerse themselves in pivotal moments from the history of the universe. Imagine being transported to the heart of the Big Bang or witnessing the formation of a galaxy, experiencing these monumental events firsthand. With the right technology and equipment, viewers could literally walk through space, observing celestial phenomena from multiple perspectives and truly feeling like active participants in the vast, ever-evolving universe. Another exciting and innovative format in modern science documentaries is interactive infographics and timelines. These visual tools offer an engaging way to represent the complex chronology of cosmic events, from the birth of stars to the gradual evolution of planets. By translating these intricate processes into clear and visually compelling formats, viewers can better grasp the sequence and significance of the cosmos' ongoing story. The tactile experience of interacting with these graphics, be it by manipulating timelines or exploring key moments in space history, appeals to a wide range of learning styles, ensuring that each viewer can engage with the material in a way that suits them best. Combining traditional storytelling with cutting-edge technology, documentaries about cosmic events have evolved into something much more than passive viewing experiences. They now offer an interactive, captivating journey through space and time, inviting viewers to not only learn about the universe, but to actively explore it. These immersive experiences encourage curiosity and inspire questions, sparking a deeper desire to understand the mysteries of the cosmos. They don't just show the wonders of the universe, they invite viewers to engage with them, fostering a sense of exploration and discovery. What makes documentaries particularly powerful is their ability to present incredibly complex ideas in a way that is accessible to all audiences. They break down challenging concepts such as black holes, the immensity of galaxies, and the forces that drive cosmic phenomena into relatable, understandable ideas. This is particularly important for younger audiences, whose curiosity can be ignited by these visual and narrative journeys into space. By presenting the cosmos as an awe-inspiring yet comprehensible subject, these films can inspire the next generation of thinkers to dream big and question their place in the universe. The inclusion of renowned astronomers, scientists, and passionate space enthusiasts within these documentaries serves as an important source of inspiration for young minds. These figures are often depicted not just for their knowledge, but for the perseverance and passion that propelled them to make groundbreaking discoveries. Many documentaries shed light on the obstacles and setbacks these figures encountered, demonstrating that the journey to becoming an astronomer or scientist is often one of resilience. These narratives are more than just stories. They are powerful role models for the youth, showing them that success in science requires determination, critical thinking, and a willingness to keep going in the face of adversity. This portrayal of scientific exploration as both an intellectual pursuit and a personal journey resonates deeply, especially for young viewers. It highlights that science is not only about acquiring knowledge, but also about self-discovery and growth. By showcasing the challenges and triumphs of real-life scientists, these documentaries encourage young people to explore careers in science, technology, engineering, and mathematics, STEM, fields that are crucial for the advancement of our understanding of the universe. The message is clear. Anyone, regardless of their background, can make a meaningful contribution to the world of scientific discovery. Furthermore, documentaries have the power to showcase the rapid evolution of the field of astronomy. They introduce audiences to the latest advancements and groundbreaking discoveries, reinforcing the notion that scientific knowledge is constantly expanding and evolving. This dynamic, forward-moving nature of the field makes it feel vibrant and alive, rather than static or outdated. Young people are encouraged to see science as a continuously unfolding adventure where there are always new frontiers to explore. Presenting astronomy not as a finished collection of facts, but as an ongoing, exciting process can captivate young audiences and inspire them to take part in the journey of discovery. The stunning visuals used in these documentaries, whether they be breathtaking images of distant galaxies, animated simulations of cosmic phenomena, or views from world-renowned observatories, serve to make abstract concepts tangible. These visuals transform complex scientific ideas into vivid, concrete images, helping viewers to internalize and appreciate the grandeur of the cosmos. By turning space and its mysteries into something visually stunning and accessible, these documentaries spark the imagination of young people, inspiring them to dream big and embrace the challenge of exploring the final frontier. Viewer feedback plays a crucial role in shaping the future of scientific documentaries. Audiences often emphasize the importance of clarity in explanations, particularly when tackling complex topics. The most effective documentaries break down intricate ideas into simpler, more digestible concepts without losing scientific accuracy. Feedback about the use of jargon and overly technical language is especially valuable, as it can help filmmakers refine their communication to ensure that even those with little to no scientific background can engage meaningfully with the content. Another area that frequently comes up in feedback is pacing and editing. Viewers generally prefer a balanced flow. Too rapid, and crucial details may be missed. Too slow, and their attention may wane. Therefore, careful editing and thoughtful pacing are essential to maintaining viewer engagement while delivering the full depth of information. Visuals also play a pivotal role in this regard. Well-crafted graphics and animations can support the narrative by illustrating difficult concepts, whereas poorly executed visuals can detract from the overall message. Feedback on the effectiveness of these visuals helps filmmakers understand what works and what doesn't, ensuring that future documentaries are more engaging and clearer. Equally important is the emotional connection that documentaries create with their audience. Many viewers appreciate personal stories and real-world applications of scientific principles that ground the material in everyday experiences. The emotional resonance of a documentary, how characters are portrayed, how the narrative builds, and how the human element is woven into the scientific story can greatly enhance its impact. By focusing on this human side of scientific discovery, filmmakers can create documentaries that not only inform, but also deeply move and inspire viewers. In conclusion, documentaries about the cosmos, when done right, can become an engaging, immersive, and educational journey. By blending innovative technology with timeless storytelling, these documentaries not only present the wonders of the universe, but also invite audiences to participate in the exploration. They ignite curiosity, break down complex ideas, and inspire young viewers to pursue their passions in STEM fields, all while offering a visually stunning and emotionally compelling experience. In recent years, documentaries have become more than just informative tools. They've evolved into powerful storytelling mediums that captivate, educate, and inspire audiences. One such powerful approach is the inclusion of interactive components and thought-provoking questions, which can significantly enhance the viewer's investment in the subject matter. When documentary creators invite their audience to engage directly with the material, encouraging feedback or posing questions that demand critical thinking, they open the door to deeper exploration. This engagement doesn't just enrich the viewing experience, it turns passive observers into active participants in the unfolding narrative. By synthesizing viewer feedback, creators can craft content that resonates on a deeper level, continually refining their approach and making their work even more impactful. In the realm of science documentaries, one of the most profound subjects that benefits from such interactive engagement is the exploration of cosmic events. Through a carefully constructed narrative, these documentaries not only illuminate the wonders of the universe, but also reveal how deeply these events are interwoven with the fabric of existence itself. Cosmic phenomena like supernovae, black holes, and the birth of stars are not merely distant occurrences in the far-off reaches of space. They are lessons in the nature of space-time and the fundamental laws that govern all matter, including ourselves. By exploring these awe-inspiring events, the documentary unearths the connections between these celestial forces and our very own origins, inviting us to consider not only where we came from, but where we might be headed. Another central theme explored in these films is the concept of time. Unlike our human experience of time, brief, fleeting, and often measured in years or decades, the universe operates on incomprehensibly vast timescales. The life cycle of a star, for instance, spans millions, if not billions, of years. Such immense periods of time challenge our perception of our place in the universe, illustrating that our existence is but a speck in the grand narrative of cosmic history. This understanding can inspire a sense of humility and urgency to make the most of our brief time in the world, while also fostering a deeper appreciation for the present moment and the role we play in the ongoing story of the cosmos. Equally important is the documentary's focus on the importance of scientific observation and technological innovation. As humanity pushes the boundaries of its knowledge, scientists and astronomers rely on cutting-edge tools to peer into the farthest corners of the universe. By observing phenomena that are billions of light years away, they unlock secrets that could fundamentally reshape our understanding of reality. These advancements not only serve to expand our knowledge, but also reinforce the idea that the pursuit of knowledge is an endless journey, a quest that requires curiosity, perseverance, and a willingness to look beyond what is known. Through this lens, the documentary serves as a testament to human ingenuity and the importance of scientific inquiry. The emotional resonance of these cosmic explorations also cannot be overlooked. The immense scale of the universe, coupled with the beauty and mystery of its phenomena, often evokes a sense of wonder and awe. Whether it is the explosive brilliance of a supernova or the ominous, inescapable pull of a black hole, these events invite viewers to reflect on their own existence. In doing so, they foster a profound connection between the viewer and the cosmos. These emotional responses remind us of our place within the vast, intricate tapestry of the universe, a reminder that while we may seem insignificant in the grand scheme, our lives are part of a much larger, awe-inspiring story. The emotional journey sparked by these cosmic revelations doesn't just entertain, it compels the viewer to reflect on their own purpose and the broader mysteries that continue to unfold beyond our reach. As the documentary unfolds, the goal is to create an immersive, thought-provoking experience that invites viewers to explore the complexities of cosmology. The narrative will be carefully crafted, ensuring that even the most intricate scientific concepts are presented in a clear and engaging manner, making them accessible to audiences regardless of their prior knowledge. Stunning visuals, ranging from distant galaxies and nebulae to the intricate dance of cosmic forces, will not only capture the beauty of the universe, but will also deepen understanding of the science behind the phenomena. By connecting these visuals to the scientific explanations, viewers will be able to appreciate not only the aesthetic allure of the cosmos, but also the profound principles that govern it. The story itself will weave through various key topics, with each segment building on the last to create a sense of continuity and flow. This structure ensures that the viewer remains engaged and eager to learn more, with each new piece of information offering a greater understanding of the universe's wonders. The emotional journey of the viewer will encompass moments of wonder, awe, and introspection. As they reflect on the information presented, they will be invited to consider big questions about existence, questions that have captivated humanity for centuries. What is our place in the universe? What does the future hold for us in the cosmos? By making science relatable and accessible, the documentary aims to inspire a sense of curiosity that motivates viewers to explore the mysteries of the universe further. The objective is not just to present facts, but to spark a deeper desire to understand the natural world around us. Whether through the exploration of black holes, the origins of the universe, or the ultimate fate of everything we know, the documentary seeks to ignite a thirst for knowledge that will last long after the final credits roll. Ultimately, the aim of this documentary is to highlight the profound interconnectedness of all matter in the universe. It underscores that the stars and galaxies are not distant, isolated entities, but rather integral parts of the same cosmic tapestry that binds us all. Through captivating storytelling, vivid imagery, and a compelling narrative, the documentary invites viewers to step into the vast, mysterious world of cosmology, a world where every star, every planet, and every force plays a role in shaping the fate of the universe. By making complex scientific ideas engaging and accessible, the film not only educates, but also instills a lasting sense of wonder, encouraging viewers to look up at the night sky with newfound awe and curiosity about the infinite mysteries that lie beyond. The documentary delves into the boundless wonders of the cosmos while carrying a deeper, essential message: our planet's fragility. As we journey through the immensity of space, the significance of Earth must never be overlooked. The universe, with all its awe-inspiring expanses, presents a reminder that our home is a delicate speck in the grand scheme. This sense of responsibility, grounded in the marvels of outer space, is crucial for fostering a stewardship mentality, a call to preserve our planet for generations yet to come. At its core, the documentary aims to spark a profound conversation, one that encourages not only curiosity, but also tangible action in combating climate change. By connecting viewers to the cosmos, it is hoped that individuals will feel a renewed sense of purpose and an urge to safeguard the natural beauty that Earth offers. Whether through reading a book, visiting a planetarium, or simply gazing at the twinkling stars, the ultimate goal is to inspire open-minded exploration. It is a call to embrace the universe's mysteries, not just with intellect, but with an open heart, fueling a global dialogue about science, discovery, and our role in preserving the planet. As we look further into the cosmos, countless enigmas fuel our collective curiosity, captivating scientists, astronomers, and enthusiasts alike. Among the most intriguing of these mysteries are dark matter and dark energy. Together, these phenomena account for nearly 95% of the universe, yet their precise nature remains one of the most elusive puzzles in science. What exactly are they? How do they influence the structure and evolution of our universe? Solving this riddle could revolutionize our understanding of the cosmos, shedding light on everything from its current makeup to its ultimate fate. Gamma-ray bursts, one of the universe's most energetic phenomena, also remain an unsolved mystery. These intense bursts, which can outshine entire galaxies in a mere instant, raise fundamental questions. What triggers them? Are they connected to the life cycles of certain types of stars? Or perhaps the cataclysmic merging of compact objects like neutron stars? By uncovering the causes of these brilliant flashes, we can gain crucial insight not only into the life cycle of stars, but also the dynamics that govern the formation and behavior of galaxies. Neutron stars and black holes, too, present a fascinating frontier. The recent detection of gravitational waves, ripples in spacetime caused by colliding neutron stars, has provided an unprecedented look at the universe's inner workings. What do these powerful events reveal about the fundamental laws of physics, especially in conditions of extreme matter and energy? Furthermore, scientists remain intensely focused on understanding the growth of black holes and their gravitational influence on the galaxies they inhabit. These massive, invisible objects play an integral role in shaping the very structure of our universe, yet their growth mechanisms and impact on surrounding space remain largely mysterious. Then there's the enigma of cosmic inflation, the rapid expansion of the universe right after the Big Bang. This extraordinary event, which occurred in the first moments of the universe's existence, has puzzled researchers for decades. What triggered this sudden, explosive growth? And how did it set the stage for the universe we observe today? Understanding this phenomenon is no easy feat, but it holds the key to unlocking some of the universe's most fundamental questions. In addition to these cosmic puzzles, there are the spectacular events of stellar death, supernovae. These explosive deaths of massive stars are not merely destructive. They are crucial to the very fabric of existence. Each supernova scatters elements such as carbon and oxygen throughout the universe, enriching the cosmic landscape and providing the building blocks for new stars, planets, and even life itself. As we observe these cataclysmic events, it becomes evident that we are not separate from the universe. We are intimately connected to it. The elements forged in the cores of dying stars are the same ones that form our bodies, the Earth, and everything we know. Moreover, cosmic events serve as a window into the vast processes that shape galaxies. The collision of galaxies, for instance, offers insights into the gravitational forces at play across the universe. Observing these galactic mergers allows scientists to explore the colossal timescales that far exceed the human lifespan. These vast epochs stretch the limits of our understanding and challenge us to think beyond the constraints of our day-to-day existence. We are but a moment in a universe that has been evolving for billions of years. Each new discovery, whether it be the merging of black holes, the expansion of the universe, or the secrets of dark matter and dark energy, forces us to rethink our place in the cosmos. It compels us to question not only the origins of the universe, but also the fundamental laws of physics that govern it. These revelations push the boundaries of knowledge and deepen our understanding of how celestial bodies interact on the grandest scales. They fuel our curiosity and ignite our fascination with the infinite mysteries that lie just beyond our reach. As our exploration of the cosmos continues, it becomes increasingly clear that we are only scratching the surface. Every new discovery adds a layer of knowledge, but more importantly, it instills a sense of wonder and awe that transcends the limits of scientific inquiry. The universe is vast, intricate, and endlessly complex, and with each new revelation, we gain a little more insight into its true nature. The more we learn, the more we realize that we are part of an extraordinary cosmic narrative, a story that stretches back billions of years and will continue to unfold long after we are gone. Yet, this journey is not without its challenges. Filming cosmic events presents a unique set of obstacles, both technological and logistical. The very phenomena we wish to capture are often as elusive and dynamic as the laws of nature themselves. The immense distances, hostile environments, and complex variables make capturing these events a monumental task. But despite these challenges, the pursuit continues, driven by the desire to understand not just the universe, but our own existence within it. This documentary, then, is more than a record of the cosmos. It is an invitation to explore, to question, and to marvel at the boundless universe around us. It urges us to look up at the night sky with renewed curiosity, to recognize the delicate balance of our planet, and to take action to ensure its preservation for the future. In the end, it is not just about uncovering the mysteries of space. It is about embracing our responsibility to the Earth and to each other in the vast expanse of the cosmos. Cosmic filmmaking presents a series of remarkable and complex challenges, many of which stem from the vastness and unpredictability of the universe itself. One of the most significant obstacles is the sheer scale and distance involved in capturing cosmic events. Whether it's documenting the activity of distant galaxies or the explosive details of a supernova, filmmakers must contend with the immense distances, often spanning millions or even billions of light years. This enormous scale means that traditional filmmaking techniques simply won't suffice. Instead, it necessitates the use of highly advanced telescopes, each equipped with cutting-edge imaging technology capable of capturing the most detailed visuals possible. The journey to capture these breathtaking images is not an easy one. Building and optimizing these sophisticated instruments can take decades, with constant adjustments and improvements. Given the unpredictable nature of cosmic phenomena, timing is everything. Many events, such as solar eclipses, meteor showers, or even the precise alignment of distant stars, occur within brief and narrow windows. A fleeting moment of cosmic perfection can disappear in the blink of an eye, and planning a film shoot around such rare occurrences requires meticulous preparation and perfect coordination. On top of that, the weather on Earth poses a constant threat to clear visibility. Cloud cover can easily obstruct the view, forcing teams to adapt quickly, sometimes requiring them to relocate to different parts of the globe at a moment's notice, all in hopes of capturing that single, unrepeatable moment. The challenge doesn't end with capturing the visuals. It extends into the realm of data management. Every moment spent observing the cosmos generates massive amounts of data, and sifting through it all to find the most compelling footage is no small feat. Filmmakers are often faced with analyzing hours or even days of raw footage, all while using advanced software and computational techniques to process this information into something meaningful. Transforming this data into stunning images and videos requires an intricate understanding of both the science and the technology involved. It is only then that the grandeur of the universe is made visible, and the cosmos is conveyed to the audience in all its vastness and mystery. Collaboration is another critical aspect of cosmic filmmaking. Unlike traditional documentary filmmaking, where a single team may be enough, cosmic filmmakers rely heavily on interdisciplinary teamwork. Astronomers, scientists, and filmmakers must come together to ensure that the visuals accurately represent the science behind them. This collaboration often takes place in remote locations, sometimes even in space itself, where the challenges of logistics and communication become even more profound. The need for synchronized timelines, clear goals, and shared resources makes the process highly complex. However, it is this very collaboration that ensures the authenticity and accuracy of the final product, helping viewers not only appreciate the beauty of the universe, but also understand the scientific principles at play. Yet, even with the most precise teamwork and planning, the task of documenting the cosmos is often clouded by misinformation. The complexities of scientific concepts, coupled with sensationalism, can easily lead to confusion or misconceptions about the universe. To combat this, clear communication becomes crucial. Filmmakers must prioritize education, breaking down complex ideas into easily digestible segments that demystify the universe for the audience. Presenting these ideas in a straightforward manner allows viewers to better grasp the intricacies of the cosmos, fostering a deeper understanding. In addition to simplifying the narrative, encouraging critical thinking plays a pivotal role in addressing misinformation. By empowering individuals to question sources, analyze data, and seek reliable information, we can help them distinguish between fact and fiction. Educational initiatives have a major role to play here, providing resources that align verified scientific findings with the reasoning behind them. Collaboration between scientists, educators, and media outlets can further strengthen this effort, creating an environment of trust and transparency that is essential for combating misinformation. Public participation is another key factor. When scientists actively engage in public discussions, sharing their latest research and discoveries, they can directly challenge misconceptions and ensure that the truth prevails. In today's world, social media and online platforms serve as invaluable tools to disseminate accurate information to a wide audience quickly. As we continue our journey to explore the mysteries of the universe, fostering a culture of inquiry and open communication will help ensure that we stay grounded in fact, not fantasy. This is crucial if we are to preserve the integrity of our understanding of the cosmos and maintain the public's trust in the knowledge we uncover. Producing a documentary on cosmology and science, while thrilling, brings its own set of technical hurdles. Communicating intricate concepts in a way that is both engaging and easy to understand demands a high level of skill and expertise. It often requires sophisticated graphics, animations, and visualizations, tools that are not only technically demanding to create, but also crucial in ensuring that the astronomical phenomena being depicted are represented accurately. Inaccuracies in these visuals can easily lead to misconceptions and confusion among viewers, undermining the very purpose of the film. Equally important is the quality of the audio and video recordings. Filming experts and researchers in a way that captures their insights clearly, without distraction, can prove difficult, especially in less than ideal conditions. Interviews conducted in noisy environments or poor lighting conditions can detract from the production value, making it harder for the audience to fully engage with the material. Ensuring that every aspect of the production meets the highest standards is essential in conveying the awe and complexity of the universe to viewers in a meaningful way. In conclusion, the challenges of documenting the cosmos are vast and multifaceted. From navigating the immense distances between celestial bodies to combating misinformation and managing the overwhelming amount of data, every aspect of cosmic filmmaking requires precision, patience, and collaboration. But through innovation, teamwork, and a commitment to accuracy, filmmakers are able to capture the wonders of the universe, allowing the public to experience the beauty and mystery of the cosmos in ways never before possible. In the intricate world of documentary filmmaking, the challenges extend far beyond the camera lens, especially when attempting to capture the awe-inspiring mysteries of the cosmos. One of the most critical hurdles is securing access to telescopes and observatories. These scientific institutions, often situated in remote locations, are not only physically difficult to access, but also require careful coordination and planning with various organizations. This logistical challenge demands precision, as these facilities are pivotal to filming the grandeur of celestial bodies and phenomena. Without proper arrangements, even the most stunning cosmic visuals could remain elusive. Once the footage is captured, the true challenge shifts to the editing room. Here, editors face the monumental task of weaving together hours of footage, interviews, and scientific explanations into a seamless narrative that captivates the audience. Balancing the dense, often complex scientific content with the flow of the story is no easy feat. Editors must cut away from intricate details at times to maintain the pacing of the documentary, ensuring that viewers stay engaged without sacrificing the core message. It's a fine line to walk, preserving the scientific accuracy while creating an engaging experience. In doing so, editors aim to create a story that's not only informative, but also emotionally resonant. Yet, the technical difficulties don't end with editing. Another challenge that emerges is accessibility. Many documentaries on cosmic phenomena aim to educate the public, but this requires translating high-level scientific concepts into language that is relatable to a broader, often older audience. Crafting a narrative that's understandable to viewers with little or no background in science involves mastering the art of storytelling. Producers must ensure that complex theories aren't overwhelming, but instead presented in a way that sparks curiosity and understanding. At its core, a documentary on the universe is a testament to the hard work and creativity of the entire production team. The goal is always to ensure scientific integrity while crafting a narrative that can capture the imagination. A documentary must ground itself in established scientific research, tapping into reputable sources and expert opinions to avoid any distortion of facts. Accuracy is the foundation, but it's the way that information is communicated that truly matters. The challenge is in conveying the immense complexity of the cosmos while making it digestible and even entertaining. One way to achieve this is by using analogies that simplify challenging concepts. For instance, comparing the life cycle of a star to the stages of a human life helps illuminate the stellar process in a way that is more relatable to the audience. Moreover, animations or visual aids can work wonders in enhancing the viewer's understanding of complex phenomena. These visual tools not only clarify ideas, but also spark the imagination, allowing viewers to see abstract concepts in a more tangible way while staying grounded in scientific fact. The power of storytelling also cannot be underestimated. By focusing on pivotal moments in the history of space exploration, documentaries can draw viewers into the human side of cosmic discovery. Narratives that revolve around groundbreaking discoveries, the curiosity that drives humanity, and the unyielding quest for knowledge can transform dry scientific facts into an emotional journey. This approach not only entertains, but also honors the scientific process and the dedicated individuals who have contributed to our collective understanding of the universe. Ultimately, the overarching aim of any cosmic documentary is to bridge the gap between the scientific world and the general public. It's about presenting the marvels of the universe in a way that retains their complexity, but is accessible enough to inspire lifelong learning. By engaging audiences with the beauty and mystery of space, documentaries create a spark of curiosity, encouraging viewers to delve deeper into the wonders of the cosmos and to explore further. A significant challenge, however, lies in dispelling the many misconceptions that people hold about the universe. For example, a common misunderstanding is the belief that the Milky Way is the only galaxy in existence. In reality, the observable universe is home to over 2 trillion galaxies, each teeming with billions of stars. This staggering number challenges the notion that our galaxy is unique, making it a fascinating point of contemplation. The sheer size of the universe can be difficult to grasp, stretching far beyond our immediate experiences and overwhelming the mind with its boundless vastness. Another prevalent misconception concerns black holes. Many people imagine them as cosmic vacuum cleaners, sucking everything in their path. However, black holes are not vacuum cleaners in the traditional sense. They are massive objects that exert gravity, much like any other celestial body. The key difference, though, is that their gravity is so intense in a localized region that it warps the fabric of space-time. Contrary to popular belief, you could safely orbit a black hole provided you are at a safe distance, much like the Earth orbits the Sun. This redefinition of the black hole's nature challenges the dramatic but misleading portrayals we often see in popular media. Additionally, a common misunderstanding involves the concept of a light year. Many mistakenly think of light years as a unit of time, when in fact a light year is a measurement of distance. It represents the distance that light travels in 1 year, about 6 trillion miles. This unit is essential for understanding the vastness of space, but it can sometimes obscure the true scale of the universe and the challenges involved in space exploration. Light years are a crucial tool in comprehending the mind-boggling distances between celestial bodies, yet they can often leave the viewer with a sense of disconnection from the true magnitude of space. Lastly, there is the idea of empty space. Many people assume that space is a true vacuum, an empty void. In truth, space is far from empty. It contains low-density gas, dust, and even tiny particles produced by cosmic events. These seemingly invisible elements contribute to the intricate web of the universe and highlight the complexity of space. Recognizing the nuances of what constitutes empty space is key to fully appreciating the universe's multifaceted nature. By addressing these misconceptions head-on, documentaries can illuminate the real workings of the cosmos, offering a more accurate and nuanced understanding of space. It's this blend of captivating storytelling, scientific accuracy, and engaging visuals that allows documentaries to reach the hearts and minds of their audiences, fostering a deeper appreciation for the universe and sparking curiosity for years to come.